all of you to the 26th Conference of the Islamic World Academy on Sciences on Artificial Intelligence and Nanotechnology Nexus. We start this conference by an address of His Excellency Professor Adnan Badran, the President of the Islamic World Academy of Sciences. Professor Badran.
Yeah. Good morning, everyone. I do thank you for attending our conference. Your Excellencies, fellow scientists, and colleagues. It's a great pleasure for me to welcome you at this 26th conference of the Islamic World Academy of Sciences, IAS, convened under the theme Artificial Intelligence and Nanotechnology. This important event is organized in cooperation with the Higher Council for Science and Technology in Jordan. And I do appreciate their contribution to this conference. Today, we stand at a crossroads of two revolutionary fields: artificial intelligence, one field, and another important field, which is a frontier area of science, nanoscience, or nanotechnology. Each, in this own right, has reshaped the scientific arena and technological arena and landscape of our era. Together, their convergence opens a new horizon to discovery and innovation across every field, from health, medicine, water, energy, food security, and ecosphere. And advanced new materials. This nexus represents more than a scientific intersection. It is a transformative force that can redefine how we understand design and interact with the world around us. This convergence is going to change our future. It's going to change our world, and is going to open new venues of science and technology. It holds the key to achieving greater efficiency in everything, sustainability, and resilience, goals that they are at the heart and the center of our collective efforts and pursuit of human dignity, to reach human dignity and economical development, and overcome poverty and open new working opportunities, particularly for the youth. IAS, since its establishment, has served as a beacon of scientific dialogue and cooperation among scholars, innovators, policy makers across the across the Islamic world and beyond. Through conferences like this, we aim to inspire the exchange of ideas and contribute to shape our future and region strategies that integrate advanced science and technology into sustainability, development, and better future of future generations. Let us, through this gathering, reaffirm our collective resolve to harness the power of AI and nanotechnology, not only as tools of innovation, but as instruments of progress, equity, and sustainability for the benefit to us all in the Islamic world and beyond. Thank you very much for your participation on Zoom across the Islamic world. And we are looking for a successful gathering and inspiring conference on an important issue for all of us in the Islamic world: artificial intelligence and nanoscience. Thank you.
Thank you, Excellency Professor Badran. It has been the tradition in these conferences to read two messages from the patrons of this academy. And they will start with the message of His Excellency, the President of the Islamic Republic of Pakistan, who is the patron, as I said, of this academy. The message of His Excellency will be addressed by His Excellency, Professor Muhammad Iqbal Choudhary, the Coordinator General of COMSTECH. Excellency.
Thank you very much. Bismillahir-Rahmanir-Rahim. Good morning and Assalamu alaikum wa rahmatullahi wa barakatuh. His Excellency, dear brother, Professor Dr. Adnan Badran, the President of the Islamic Academy of Sciences, our teacher, His Excellency, Professor Dr. Atta-Ur-Rahman, who is there next door, but I didn't want you to crowd the room. I wanted him to have a peaceful sitting. And my very dear brother, Professor Dr. Ilyas Baidoun, distinguished colleagues, this is an honor to speak at this occasion and to read a very important message of His Excellency, the President of Pakistan, Mr. Asif Ali Zardari, who is the Patron of Islamic Academy of Sciences. And in his speech, in his message, he writes, I wish to congratulate Islamic Academy of Sciences on organizing 19th conference on achieving socio-economic development in the Islamic world through science, technology, and innovation. I also wish to appreciate the government of Hashemitizing this important organization as this important conference. I welcome the eminent scientists of the Muslim world, including the fellows of Islamic Academy of Sciences and all other participants, and wish them productive deliberation during conferences like this. Provide a unique opportunity to scholars to learn from the knowledge and experiences of their peers, and also to highlight the latest advances made in conducting research and benefiting from it. The mutual sharing of expertise and knowledge enriches sum total of human knowledge, and it is a great benefit to the entire mankind. The pyramid of knowledge was not raised overnight. It was built brick by brick over the past centuries, in which sharing of knowledge has played a pivotal role. Indeed, conferences like this one, are the building blocks of pyramid of knowledge. A great challenge that lies ahead of us is the threat to environment and ecosystem posted by overuse of carbon-based energies and resource depletion. Climate change and global warming have already started taking a deadly toll on our continents, our wildlife, our food resources, on the life of every individual man and woman, child on our planet. The issue of climate change has posed even greater challenges to the member of Organization of Islamic Cooperation, who are also faced with the challenges of rapidly growing population and depleting resources available to them. The situation therefore calls for deploying our best brains so as to take full advantage of scientific advances and confronting the challenges faced by us all. I am confident that IAS, in collaboration with COMSTECH, will take major actions to meet these challenges and taking all necessary measures to address it at the OIC and a global level. The Islamic Academy of Sciences can play an effective role in bridging the gap between the Islamic world and the West. Our scientists and the fellows of the Islamic Academy of Sciences possess the abilities and have the potential to devise credible strategies and action plans for OIC member states to pursue their development agendas while protecting the environment at the same time. Many will look forward to the outcome of this deliberation of this important conference and its recommendation for helping the Muslim world science for improving the quality of life of their citizens. At the end, it is extremely important that these deliberations are turned into actions. I wish the 19th conference all success in its endeavor and pray for successful accomplishment of its goal. This is the end of the message. I'm extremely grateful. We are pleased that at the OIC-COMSTECH we are working closely with our brothers in Islamic Academy of Sciences and have organized many events in past 2-3 years, that we wish to have this productive collaboration move forward in future as well. Thank you very much. Wassalamu alaikum wa rahmatullahi wa barakatuh.
Thank you, Excellency Professor Choudhary. I come again now to His Excellency Professor Badran, delivering the message of His Royal Highness Prince El-Hassan bin Talal, the founding patron of the Academy. Professor Badran.
Thank you, Ilyas. Well, I'm here back again. I hope you don't feel tired hearing me, but I will be talking to you now on behalf of His Royal Highness Prince El-Hassan, saying his words. Distinguished IAS fellows, scientists, ladies and gentlemen, it is a privilege for me to be here and to address you today at this an important gathering and meeting of IAS around an important topic, artificial intelligence and nanotechnology nexus. We are meeting at when science and technology are no longer peripheral, but they are at the heart and center of our development and our progress. So artificial intelligence and nanotechnology is going on its own right, is going to change our future. I hope to progress and not to have more problematic regions and conflicts. It will reshape the landscape of our economies and also our conception of what it means to be a human. The human face is so important at this time to express the future of future generation with this advancement of science and technology throughout the world. The question for us today, it is not only what this technology can do, but rather what we will do with them. For what shall we embark on them? And to what end? In the Islamic transition, knowledge is amana. Amana is a sacred trust. Science and the highest expression is not separate from ethics, but integrated with it. It is not really looking for domination, but the future for all. Happiness and mercy, justice and stewardship for all. It was on this conviction that we established the Islamic World Academy of Science more than 3 decades ago with the headquarters in Amman. IAS was never intended to be merely repository of expertise, but a beacon for ethical inquiry, cultural dialogue, and international cooperation. It sought to reinvigorate the great legacy of science, al-ilm, of learning in our region, and also to ensure that science remain the backbone of our progress and our life in values, in dignity, and building the human face. Today, as we stand at the intersection of artificial intelligence and the manipulation of matter at the nano scale, this mission is more than relevant than ever. Ladies and gentlemen, the potential of this convergence is vast. We speak of nano-enabled diagnostics guided by AI that could detect diseases and before they take action and they take hold. Precision of agriculture, the progress in agriculture that will feed the growing population of the world. This is very important to interact with the progress and the healing of land. Energy system is so important to life. It's going to change as a result of AI and nanoscience. And also optimization through machine learning and machine intelligence to sustain our planet for the future. Therefore, I urge you to proceed with both imagination and humility. for what? For our future. We may master the code and the molecule, but we cannot really master the ethics and morality as concluded in our discoveries for the future. It is my belief that the global scientific community must now establish or embrace a broader mandate, not only to innovate, but to integrate and interrogate, to ask not only can we, but we should ask, should we? And also we should ask, for whose benefit? We must ensure that governance of science is not a privilege of the few, but the right of all people on this planet. That open science and open access to science and open dialogue on science are so important. They are not slogans, but structures for our future. Structures that bind us together across borders and across the world. Cultures, different cultures should combine and interact for better understanding through science. Science could be the backbone of interactive culture among different people of the world. Could be a social and material backbone to resolve conflicts among nations of the world. Geography and demography, traditions should be taken into consideration and respect. No occupation on overcoming borders over the others because of power. Dialogue is the solution for all our conflict. And these, I must once again emphasize the role of institutions like ours and like others to solve and resolve problems around ethics and morality. The promotion of interdisciplinarity shall be our right to the future of solving climate change and other interdisciplinary problems we may face. Dear colleague, as we gather for this conference, let us remember that we are not morally advancing technology. We are shaping the human face and the future generations. We must ask, how do we ensure the intelligent machines that do not erode humanity? How do we protect our biosphere even as we redesign it? And we should ask our question, and how do we transmit the values of compassion, mutual respect and human solidarity through the language of science. The answers will not come from a single nation or single laboratory or single world power. They will come from dialogue. They will come from encounter. They will come, I hope, from rooms like ours, from a conference like ours, from space of like ours of IAS, where the minds of Islamic world scientists meet and discuss in mutual respect and shared purpose. May this conference mark a new chapter in how we think, how we create, and how we innovate, and how we care, and how we share. I thank you, dear colleagues, for your dedication to the noble endeavor, and I wish you a most fruitful and inspiring conference. Wassalamu alaikum wa rahmatullahi wa barakatuh.
Thank you, Excellency, Professor Badran. Now we'll start the first session of the 3 keynote speakers. May I kindly ask the speakers to restrict to the time allocated to them. Each speaker is given 30 minutes according to the program. And it gives me great pleasure to start with our first keynote speaker, Professor Atta-Ur-Rahman. I am very privileged to introduce you, Professor Atta-Ur-Rahman. Professor Atta-Ur-Rahman is the most decorated scientist of Pakistan, having won 4 civil awards, including Tamga Imtiyaz, Sitara Imtiyaz, Hilal Imtiyaz, and the highest national civil award, Nishan Imtiyaz. Professor Atta obtained his PhD from the University of Cambridge in the year 1968, and he has over 1,600 international publications. Professor Atta was elected as a fellow of the prestigious Royal Society in London, and he is the only scientist in the Islamic world who has been fellow of this society, which is 370 years old. He won the most prestigious UNESCO Science Prize and was elected as an honorary life fellow of King's College at Cambridge University. And Professor Atta-Ur-Rahman got 4 honorary doctorate degrees by leading institutes, including Cambridge University, Coventry University, Bradford University, Asian University of Technology at Thailand, and the University of Technology at Malaysia. Professor Atta-Ur-Rahman is given the prize of TWAS for institution building and the High Civil Award by the Australian government and the highest scientific award of China. Many research centers in China, Malaysia, Pakistan has been named in his honor. Professor Atta-Ur-Rahman was the Federal Minister of Science and Technology, Federal Minister of Education, and the Chairman of Higher Education Commission with the status of a Federal Minister in Pakistan. Professor Atta was the coordinator General of COMSTECH. He is currently Professor Emeritus at the International Center of Chemical and Biological Sciences, which is internationally recognized at the UNESCO Center of Excellence, as UNESCO Center of Excellence. Professor Atta-Ur-Rahman will address us now.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Your Excellency Professor Adnan Badran, my dear Professor Iqbal Choudhary, who is actually in the room next door here in COMSTECH, Professor Ilyas Bedoun, Fellows of the Islamic Academy of Sciences, ladies and gentlemen, Assalamu alaikum wa rahmatullah. Very good morning to you. Ilyas, just a clarification. You said the time, what the actual time allocated to me is according to the program? 30
According
minutes.
to the program, 30 minutes, my dear.
Okay, good. Fine. Thank you very much, Ilyas.
Thank you. Thank you.
So, well, it is a real pleasure to be talking this morning. I have many friends, lifelong friends in Jordan, and we have worked together and have many publications together. Professor Salim Sabri, Professor Musa Nazar, Professor Abu Zarga, Professor Amal Al-Aboudi, and I could go on for half an hour. So it really is a pleasure to be talking here about a topic of a great importance, which is the nexus between artificial intelligence and nanotechnology. So let me just go to the beginning. So first, nanomaterials, what makes them unique? Well, one of the persons I knew very closely, Harry Croto, he was at Sussex University, and he and Smalley and others in the US were looking at the chemistry of stars. And they were looking at polycyanoacetylenes, how they were formed in stars, and they decided to heat graphite with strong lasers at high temperatures and discovered this very interesting compound which looks like a football made of pure carbon of fused 5-membered and 6-membered rings. They shared the Nobel Prize for this work, and this really, while the concept of nanotechnology had been proposed earlier, as will be portrayed in the lecture later by Professor N.M. Butt, who I recognize also, who is here with us, but this I regarded it as an important milestone in the development of nanotechnology. Then came graphene in 2004, where again from graphite they could remove fine layers of carbon which have a honeycomb pattern, and these monolayers were just 1 atom thick, and they had unique properties, and this again led to some more Nobel Prizes. And what makes graphene so extraordinary? Firstly, it has an excellent electrical conductivity because electrons can move freely through it. It is excellent strength. It is about 200 times stronger than steel and is now being used on the one hand for construction, and on the other hand because of its properties for electronics and for other areas. It has excellent transparency. It is very flexible and excellent thermal conductivity, better than diamonds actually in terms of thermal conductivity. And what gives it its unique properties is firstly its increased surface area. These are particles of 10 to the minus 9th of a meter, so huge surface area, surface area to volume ratio. So this gives them enhanced interaction with surrounding molecules, with chemicals, with enzymes, with other metals, with catalysts, and gives them special properties. At the nanoscale, you also start seeing some special quantum effects. And these quantum effects have led to the development of quantum dots, which exhibit size-dependent fluorescence, and a number of applications which I will describe to you later. Then the size-dependent properties, because of this, have resulted in their melting points in optical absorption and magnetic properties. They can vary with their nanoparticle size. And they also have enhanced mechanical properties. For instance, carbon nanotubes, which are now widely used in industry, are very strong and stiff because of this special molecular structure. this is nanotechnology on the one hand. Then you consider artificial intelligence, which is also evolving. And when you combine the two, the nanotechnology, artificial intelligence nexus, and their industrial applications, this is what this conference is all about, and this is what I will focus on next. Firstly, let us consider what is happening in this nexus in medicine and biotechnology. We have now rapid AI-driven lipid nanoparticles, which allow vaccine development to be done faster. And this was evident in the vaccines against COVID, which were recently developed. And the sales in this area are phenomenal. So each companies is shown here, Moderna, BioNTech, and others have sales in billions of dollars and euros. Medical imaging can be enhanced using nanotechnology, nano contrast agents combined with AI, and this again is being used and with sales of billions of dollars. AI is being combined with wearable nano sensors, and this allows the continuous measurement of biomarkers, and the AI transform these signals into actionable insights for doctors and patients. Again, sales in terms of billions of dollars of companies like Abbott and Dexcom. Nanodiagnostics and AI readers are being combined so that you can have early detection of disease and see the biomarkers very clearly and interpret the results very accurately. Again, $42 billion worth of sale in this area by Abbott alone. AI-guided nanomedicines and theranostics, gold nanoparticles are being used to deliver targeted compounds against cancer. And this has improved the recovery rates of patients. And this precision-guided particles are now widely used in medicine as well. Bone implants, again, you have AI and surgical planning combined with nanotextured bone implants. And companies like Stryker last year had revenues of about $22 billion in this area. Let's turn to another area, that of energy. And in the energy area, you find nanostructured thin films being used in solar panels. And these are much more effective and with much higher energy yield than normal panels. And these are coming, these you can put on your windows or on top of your buildings, just on the walls, and they are much more energy efficient. Perovskite is a material which is now used in such solar cells combined with AI, and they have resulted in much improved efficiencies also. For nanocatalysts with AI combinations, you find the costs are significantly lower, and the fuel cell durability increases. So the hydrogen energy systems are being optimized, and these companies, Ballard and Plug Power, had sales last year of almost $70 billion. So these are all huge areas and rapidly evolving areas which we are seeing around us. This nexus between nanotechnology and artificial intelligence. In electric cars, you find that nanostructured electrodes are being used, which are boosting the charge speed and lifespan and ensuring the safety and efficiency. Again, very huge sales of $56 billion of just one company alone. Turning to another area of water and agriculture, and talking of the same nexus, we find that nanomembranes combined with AI operations are being used to improve plant operations and predictive maintenance. The Japanese company Toray is here again, is one of the leading companies in this field. Nanofertilizers are much more effective than normal fertilizers, and they are being combined with artificial intelligence, with the result that yields are increasing, and you need to use lesser amount of fertilizers, which saves a lot of costs. And again, this is a hugely growing area. Turning to the area of construction, we find that nanomaterials are being used to improve insulation, and reduce emissions. And combined with AI, the energy costs are being reduced. In Aspen, for instance, aerogels and Cabot sales were about $450 million last year. Nano coatings, again, in protective textiles, these are being used along with AI to give antimicrobial properties to fabrics and impart odor resistance. Aerospace nano coatings, again, you have the combination of nanomaterials and artificial intelligence to optimize maintenance and reduce risks. Drag, ice, and wear in aerospace is reduced with these nano coatings. Turning to electronics, I'm just giving you an overview of what is going on. We find that quantum dots, which have been now widely used in industry, are being combined with AI to give enhanced visual clarity and reduces the energy being used. And these are now widely used for picture processing. Many companies across the world are using these too. Environmental nanosensors are available, which again combine nanosensors with artificial intelligence, and they are supporting the detection of very minute amounts of pollutants and gases which are contaminating the environment. We find that nanostructured catalysts are being used also for driving many chemical reactions and offering greener pathways for fuels and materials. Another important development has been artificial intelligence combining with quantum computing. On the one hand, you have software, AI. On the other hand, you have quantum computing, which is transforming the way computing will be done tomorrow. The quantum computers today are much faster than the fastest supercomputers available. And with this, we'll be designing new life forms. We'll be unraveling the origins of the universe, working on neuroscience, and we'll be able to do many things which are impossible to do today. An example is the quantum chip Willow, which Google had announced, which the fastest supercomputer would take 10 to the 25 years to do, much longer than the life of our universe. What that time would take for the fastest supercomputer, the quantum computer can do this in 5 minutes. So this just tells you the enormous change in civilization that we are just on the verge of when quantum computing merges with artificial intelligence and nanotechnology. In Pakistan, let me say, we are very fortunate that Dr. N.M. Butt is here in the conference. When I was the Minister of Science, I formed a National Commission of Nanotechnology, which was headed by Dr. Butt, and that has done wonderful work in Pakistan and created many programs which Dr. Butt will talk about. So thank you, Dr. Butt, for all your wonderful services to this country and to the field of nanotechnology. At my center in Karachi, I have set up the LEJ Nanotechnology. We have set up the LEJ Nanotechnology Center at Karachi University. This is the center which private participation from Latif Ibrahim Jamal Sahab, who is part of the HEJ Foundation. He heads it as its chairman, and this is focusing on nanopharmaceuticals. Professor Iqbal and I have been closely involved in this development. I will just end here by showing you one slide which shows the transformation of that Pakistan has taken place. At the bottom is the year 2000, and this is the SCIMAGO rankings of Pakistan in various disciplines. At the bottom, if you read, Pakistan had rankings of 54, 59, 60, 96 in the world. That was the year 2000. At the top, you see in 2023, they had moved to 15, 17, 20s. So a remarkable, these are SCIMAGO rankings, subject-wise, agriculture, physics, and so on. And something remarkable has taken place in Pakistan, which has no precedence in any other country in the world in such a short period. And this is our comparison with India in terms of research publications per capita. Pakistan is green, India is red. Extreme left the year 2000, extreme right is the year 2022. And you see the green has gone, and we have overtaken India in the year 2017. and we are now about 10 or 15% ahead of India in per capita research output, not in actual numbers, but per 10 million population. This again is no small achievement. My final slide, I like to end here by saying that there's a huge amount of potential in the Islamic darkness, because we haven't realized that our real wealth is our children. It is only through education, through science, through technology and innovation that we can progress. I will refer to one university, my own University of Cambridge, from which I received both a PhD and an honorary Doctor of Science degree. 125 Nobel Prizes have been awarded to faculty members of just one Western university, University of Cambridge. 34 Nobel Prizes have been awarded to just one college of that university. One college, 34 Nobel Prizes, Trinity College. And one of my colleagues at King's College at Cambridge won 2 Nobel Prizes, Fred Sanger. So it's time for us to wake up. There's not a single Nobel Prize awarded in science in the last so many 100 years, whenever the Nobel Prize was introduced to any person in the Islamic world for work done within the Islamic world. All the persons who have won Nobel Prizes, which was done from the Islamic world, were done in Europe or in USA. So we live in the darkness of superstition and ignorance. It is time to wake up and realize that our future lies in our children. Thank you very much. I'm most grateful. I have not taken too much time, but I have tried to give you a quick overview of what is going on in the field and the tremendous opportunities that exist.
Thank you, Professor Atta, for an excellent lecture. Now I come to our next distinguished speaker, Professor Munir Nayfeh, who is an atomic physicist renowned for his groundbreaking work in nanotechnology. He got his BS and Masters from the American University of Beirut and his PhD from Stanford University. He worked as a lecturer at Yale University, consultant of the Argonne National Laboratory, and he is currently Professor of Physics at the University of Chicago, at the University of Illinois at Urbana-Champaign. Professor Nayfeh co-authored 4 books on nanoscience and on nanosilicon, and he co-edited 3 books on laser science and technology. Dr. Nayfeh holds the largest number of patents in nanosilicon worldwide, 23 issued in US and Europe. He is the founder, chief editor of 3 nanotechnology companies, and he is the president of the network of Arab scientists and technologists abroad. He is fellow of this academy. He received the Beckman, AT&T Industrial 100 and the NEDI 100 awards. Professor Nayfeh. 30 minutes, please.
ما في صوت.
هلا بيجي. متطورين زيكم بأربانا شامبين. You are more advanced on Urbana-Champaign.
Thank you, Elias, for this nice introduction. I will give you my view as a physicist. Do you hear me?
Yes, yes.
Yeah, I will give you my view as a physicist of the crust of the matter of the interaction between AI. If I can get it going. Do you see my slides or?
No. Now we are, yes.
Now you see my slides?
Yes. Eh? No, it's okay.
من عنده؟
Yeah, so my talk will be basically when artificial intelligence and nanotechnology and computing team up, we will get a new revolution.
عندهم.
So what is the problem at hand? When nanotechnology came along, especially indirect band gap material like silicon, the backbone of industry, the computations was behind the experiments. So experimentally, it was a breakthrough. In nanotechnology, we succeeded in the synthesis, characterization, and incorporation of nanostructures in advanced devices. However, there were some difficulties in theory. Simulations was behind, device design was behind, and so the field of nanomaterials was experimentally ahead and the theory was lagging. There comes artificial intelligence. So what is artificial intelligence? Artificial intelligence, we all know basically artificial intelligence, as we will see in a few minutes. The hardware is actually refers to an advanced computer, including robot systems. And the functionality, it aims at getting as much as possible some of the human intelligence, such as learning, problem solving, and decision making. Of course, this requires a lot of computer science. So the software is basically creating physics concepts of algorithms after Al-Khwarizmi, neural circuit networks, models with differential equations, which we all know are not easy to solve analytically, which will enable machines to calculate, record, memorize, analyze data, identify patterns, images, and make predictions or take actions. What is the breakthrough? Why are we talking about artificial intelligence? Because it started just like nanotechnology in the 60s, 1960s. But the breakthrough at this time is the fact that people have made artificial intelligence experimentally adapt to new inputs. And it gathered more speed and accuracy because the computers are becoming faster and more accurate. The important thing is trying to get the computer to learn from its own self rather than for programming. And suddenly, of course, physics and chemistry, not computer science, physics and chemistry, made the day by including some of the physics concepts into the benefit of solving problems. So they were awarded last year to physicists and chemists. We all know and we all heard about artificial intelligence for now, for a little while. For example, in 97, a computer at IBM defeated Kasparov in chess. So that brought it to the layman, because the layman is following chess. Then IBM computer defeated champions of Jeopardy, which we all watched when we were young or we're still watching. And then the most celebrated application, which brought it to the house, to our children, is the so-called Hey Siri, where you can ask a question to your iPhone or smartphone. And then there follows the good Google stuff. So the idea is that when artificial or the benefits of computers transcended science and technology into the field of the house, the layman, children, that's when it became much more important and much more presentable to the people. So the ability of AI to analyze data and find patterns, and I'll show you examples, that made it what it is at this time. Of course, nanotechnology, in essence, started in the late 50s, last century, by Richard Feynman, who's a theoretician, who proposed experimentally that we can take a material and build a car instead of starting with big pieces of plastic or aluminum or iron, but the atoms of these respective materials, and assemble it an atom at a time. At that time, I myself was in prep school playing with, he was counting atoms, I was counting sheep. As you could see, I was playing with the sheep. So when I landed at Stanford in 1970, exactly in 1970, Richard Feynman visited Stanford University, and my advisor, Arthur said, how can we implement Feynman's, who was visiting Stanford, how can we implement his concept in the lab? After all, we cannot see atoms at that time, single atoms or two atoms or three atoms. So I would like to remind you that how do we see objects? We see them, of course, and Al-Hassan ibn al-Haytham was key to the understanding of this concept. We understand them through our eyes, optically, because light scatters coming from the sun, from the room, from the lamp, from the candle, scatters or reflect or get absorbed by the object. So, and it comes to our eye, and that's how we see. Another method would be electronically. Instead of photons or light coming back at us, we get electrons from the material coming back at us, but we don't have a means ourselves to measure the electrons, so we measure it by a machine, such as this one. The same thing, electrons reflect, transmit, emission, and the machines are TEM, SCM, STMs, and so on. And there are more ways. For example, we can detect things by sound. The voice of some people can detect it. You don't need to look at TV. You could hear someone say, oh, that's for so-and-so. Breathing even, noise, touch, smell. And with the advent of laser light, it made many of these things. Look at this, guys, looking, they can spot an ant at a distance. And so Arthur Shallow asked his own staff, I was one of them, to see how we can detect atoms. And so I managed to get in absorption by absorbing laser light by hydrogen atom to absorb 1,000 atoms in one shot. A colleague, another student, was able to do 100, but there were sodium atoms, and hydrogen, it turns out, is the heaven for theorists, but the menace for. Then the sensitivity improved at Oak Ridge National Laboratory, where I moved, and I told them about the story of Feynman coming to Stanford. and I convinced him to start a program on this topic. And we combined lasers along with electrons. Laser produce electrons from the material to be able to detect or improve the detection sensitivity of matter down to a single atom. And so that was a major breakthrough. Physics Today wrote, encyclopedias reported, all news, industrial research, laser focus, chemistry, American scientists, optical spectrum, even the Washington Post. Then the station moved along because that was in a gas phase. And you know, when we write things, we put things on a piece of paper, on a surface. So at IBM, they were able to design a new microscope where a very sharp needle comes close to a surface, and then electrons can come off the tip or come out of the surface to the tip. And by looking at the electrons, they were able to detect or see single atoms on surfaces. And then that was seeing things. But then several groups in Japan and in Europe and in my laboratory too, we were able to convert the device which sees atoms by this sharp needle to pin an atom and drag it to somewhere else. And so we were writing with atoms, moving them around. And this is the New Scientist magazine, the British magazine. And this was the first, basically, professional report on nanotechnology at the time. I wrote a heart and the letter P. Other people designed the stamp of Stanford. The Japanese put Peace 91. This action was reported in 1992, but obviously the work was progressing over 4 or 5 years all over these labs. And then the cover of the New Scientist gave the word peace for the Japanese, put the heart, and put some of the IBM work as molecular man. I want to remind you that Prince El-Hassan came to the University of Illinois, and in 2000, about that time. And this picture was in a major newspaper in town, which was first report about my nanotechnology effort. And he saw it on the coffee table of the president of the University of Illinois. In that work, we succeeded in dispersing silicon, the dullest material in the universe, into a family of nanoparticles and different sizes, 1, and then up to 3 nanometer. And depending on the size, you will get the different colors. This is the material as you put in some solvent, different colors depending on the size. And they're all ultra small from 1 to 3 nanometer. That was on a major television station which visited my lab. And this is several reports from Nature on these nanoparticles. One of them is Let There Be Light, the story of the creation in the Bible, and that the universe was dark and turned into light, just like silicon is dark and turned into light. This is about biotechnology. This picture, this nanoparticle, and my picture was in Nature magazine, too. 3 or 4 reports about And now we define nanotechnology, the regime or the nano world, which will combine with artificial intelligence, between 100 and 1 nanometer. I sit here at 1 nanometer, the smallest particle in silicon. Remember, silicon is the backbone of the electronics industry and now sensors and all sorts of applications. And you could see that a hair on our head it contains, or the size of it is larger by 100,000, the diameter of it, 100,000 times more than the 1 nanometer. Of course, at the time, artificial intelligence was not able to simulate the structure of more than 1 nanometer. That's the problem. And so to understand, or in order to utilize to the fullest potential of nanotechnology, you need to know the structure of these nanomaterials. And so the computation power was not enough, especially after you pump some energy on these nanoparticles to see how it interacts with the environment, was not able to tell us about the positions or the structure of these nanoparticles. Only 1 nanometer. Beyond that is too much for the thing. The artificial intelligence was not yet good enough to do that. So, for example, the size range from 1 to 100 nanometer. The 1 nanometer has 29 atoms, manageable by AI. But the 100 nanometer has 29 million atoms. And so that's too much. Second problem for artificial intelligence is that when a bond forms in nanotechnology, a new thing happened after you pump some energy or remove some energy, some bonds die and some bonds are formed. And the death and birth of these bonds were not really be handled. They could not handle it by artificial intelligence till just recently. So a scientist, and the cost of computation is n cubed. It accelerates very quickly by the third power of the number of atoms. So a scientist, in order to get the benefit of these nanomaterials, needs a massive computation, meaning a supercomputer, even beyond the classical ones. You need the quantum computer. The second thing artificial intelligence brought in is the coarse graining and fine graining. When you're trying to solve a problem, if there is a region where it's not important, so you don't look at it very closely. When there is some fine details and you need to know so that you could figure out, you need fine graining. So that was brought in by also artificial intelligence. And of course, exploit symmetries. Artificial intelligence started to exploit symmetries. So you don't have to, by using symmetry, then you could minimize the amount of calculation. The other thing that the advancement most recently, especially this one, which made the Nobel Prizes, is the so-called machine learning. Machine learning means in the past, even in the 50s, in the 60s, as the computers were coming along, we had if-do loops. If so-and-so, then do so-and-so. That was some kind of intelligence. But then the scientists have to put this rule and program it. Now, these new programs can get the computer to learn outside its own gameplay, not only from pre-programmed strategies that the scientist does that. And so it's called by learning by experience. Just like when I was a freshman, you study the book, then you solve all the problems in the back of the exam of the book and check out the answers. Then you go back and see other books. That's kind of experience. Then when you go to an exam, they will never give you an example or a problem which you have not seen a similar or figured out all tricks. And the computer started to doing that on its own. And that's what made a revolution and got the Nobel Prizes going, because of the neural network. They took the way the brain works, which works in parallel. When your eyes see something, trying to analyze it, it looks for fine details, looks like big details, looks like that, and different layers of the brain handle them simultaneously. They don't wait till you figure out the details or the big things to go to the fine things, all simultaneously. That's parallel computing. So, for example, that's very useful in disease, because diseases are on the order of 100 nanometer, and they are made all from proteins. And a protein is a series of amino acid molecules stacked, just like this colored one. So it's like a Lego game. How do you stack those so that the amino acid would look like exactly the disease? Where can you place a drug, and what kind of a drug that can attach to the series attachments Lego of the amino acids? And so the breakthrough came when the computer started to learn from previous examples. So they programmed like 100,000 different cases, and the computer, when you give it a new problem, the computer would look around and see how it was done in a previous example, solved example, experimentally verifiable example, and come up with one and give you the answer to the series like this, and where you can attach a molecule and what kind of molecule can attach. That's the drug, the solution to a disease. And so scientists were able to get the protein shell of HIV involving 400 million atoms. The hemophilia, missing protein, the disease, a lot of problems with tobacco, viruses, and other common biological molecules, such as cellulose. So that's the breakthrough. Where the second example I would like to mention is the personalized, so-called personalized medicine. Cancer is, we think, or a lot of people, laymen think, that when somebody says, oh, he has a liver cancer, or the other guy has a liver, they are different. They are not exactly the same. And so the kind of medicine they need to give one is different from the others, although all of them are called liver cancer and under the same umbrella. Because of the sequence of the protein, they might be different. And the place where you could attach, or what kind of molecule you can attach to kill it, is different. And so that needs a lot of computation and the so-called protein folding calculations in order to, example, Choudhary, the liver disease. Liver disease is, here are some cells inside the liver, 4 cells. You can see the nucleus. And these red fine lines are like hairy, like hair, the one on our head, except it's a primitive type of hair. It's made of course, keratin, and a lot of women use nowadays keratin, so-called. And the problem with those is that when alcohol goes inside the liver, it interacts with these guys and it makes them brittle. They break, and the cell collapses, and you damage the liver. So we decided to take hair, which basically an advanced form of the keratin of these things, and we placed on them the nanoparticles for imaging. And we try to see some patterns where it becomes brittle, where does it crack, and pieces come out and go into the flow of the blood and create a lot of problems. Also in education, I was able to put together a story called Al-Kawn al-Wasi' wal-Nano, the vast universe and the nano, the two extremes. And this made it as one of the books by the Maktabat al-Usra al-Urduniya, by the Ministry of Culture in Jordan, published it. And in this story, I take the story of Stephen Weinberg and his Stephen Hawkins and his daughter Lucy, where they invented a method for children where you combine science fiction with science, and they went to the universe through a supercomputer, basically an artificial intelligence system. And I added nanotechnology to it, and it's a popular. If you happen to get hold of it, it would be. It was translated into Arabic by the Society, Jordanian Society of Ibtikar, and it's distributed to that. Here, for example, is an exciting conversation between the scientist, Dr. Nano, and the Cosmos, the artificial intelligence computer. He says, listen, Cosmos, you are irritating me. This is the doctor is saying, the human doctor. You are starting to speak like a scientist. I am the scientist here, not you, Dr. Nano said. Dr. Nano whispering to himself, oh my God, could be that my nanos have given him enough speed and memory to cross into life. I smell sign of human intelligence and passion. Cosmos is trying to make decisions on his own. Okay, Cosmos, the doctor said. Never mind. This project can wait. I will come sometime next week to discuss the project with you further over a cup of tea, Dr. Nano said. Then Dr. Nano thought to himself, maybe I should listen to Joe and change him back, meaning get him out of this tremendous ability to think and to act like a human, to bring him back to Cosmos the second, the previous generation Cosmos. Dr. Nano whispered to himself, but for now, let us celebrate, Dr. Nano shouted. So in conclusion, I would say you already seen that the idea of artificial intelligence, tremendous computations, pattern and image and identification, it facilitates the identification and simulation of larger systems for longer duration. And it opens, of course, it's natural to say, it opens explorations of materials and phenomena and diseases previously inaccessible due to computational limitations, revolutionizing nanofields leading to novel applications. However, as Prince El-Hassan said, there are questions, for example, ethical and security concerns. Who owns information? Worries of security, access, standards need to be put. Second thing, forget it. There can be no artificial intelligence like human. So there is a lack of flexibility in general human knowledge, passion, for example, mood, freedom, reflex, independence, self-automation, soul, state of life, and the concept of mukhayyar and musayyar. And I conclude by showing this slide, which lists several books of mine where you can get the details of nanotechnology. And I put most recently two pictures. One for the future. Prince El-Hassan mentioned the future generations. A boy who wants to become a physicist and the girl who wants to become a physician. So one is trying to advance the concepts, and one who's wants to participate in solutions, physicians like solving disease. I thank you very much for your listening, and I hope I was able to convey to you some of the major or the basic principles of both nanotechnology and artificial intelligence. Unfortunately, the time does not allow me to get into the quantum computer, in which the speed arises, because in the quantum computer, unlike the classical ones where electrons move and create current, and then we can tell there is a current or there isn't a current as a means of calculation, in quantum computers, nothing moves. The electrons, we look at the spin of the electrons, so nothing moves. That means they don't take time, so it's faster. And nothing moves, that means it doesn't produce heat, which means it's more efficient. And as to the speed, and at IBM, actually, my son Hassan, he knows the ins and outs of the quantum computer at IBM because he's actually one of the developers and worked there. And I cannot claim I know all, because he is not allowed to tell anybody else about the status and what are the problems and how are the strategies to solve them. Thank you very much.
Thank you, Professor Nayfeh, for a very interesting talk. Now I come to the third distinguished speaker, Professor Al-Jumaili, who is a professor of artificial intelligence and the Liverpool John Moores University, and a visiting professor at the World Health Organization Collaborating Center for Public Health Education and Training at Imperial College London. Dr. Al-Jumaili research is focusing on AI alongside technological tools for improving the world and making it a better place for everyone, everywhere. This has been featured in the advancements that he made in the fields of healthcare, environment, safety, security, and education at the global level. Dr. Al-Jumaili's work on AI has been awarded by the late Queen Elizabeth, has been recognized, where he was promoted to the Order of the British Empire, officers of the Civil Division of the Sid Most Excellent Order of the Services to Scientific Research. Dr. Jumaili has been among the top 30 most influential Arabs in technology and AI. He was also classified at his university as one of the top 200 outstanding people who influenced the AI. And it's with a pleasure to introduce Professor Jumaili to you. Professor Jumaili.
Thank you very much indeed. Thank you very much.
I met you 6 months ago, and I know how punctual you are on time, so I need not to remind you, Professor Jumaili. Thank you.
I'm not going to take a lot of time, because after it is, to be honest, it's very difficult to give a talk after our leading scientist, Professor Munir and Professor Rahman. So it is very difficult to touch shoulder with these big boys. So I will try my best to change my talk to get to the level where they were talking. So Dr. Munir, it is our pleasure, Professor Munir, our pleasure to
thank you
to be our name to be associated with your name. So thank you very much, and the same for Professor Rahman. Okay, so I'm not going to take a lot of time. I'm going to start talking about I'm sharing my screen, and I don't know if you can see my screen. And please,
Yes, we see it.
just is it working now? Is it moving? Is it moving when I move it?
No, it's not.
It's not moving. Yeah. Then I have to. There is something. Okay, I'll stick with this one. Okay, you can see the screen in front of you now. Yeah. And
Yes.
it's moving. Yeah. You can move
Oh,
it. Yes.
yes.
Okay. Well, thank you very much. One of the things which is I just learned from Professor Rahman, he said we are not doing very well in the Islamic world, and because we are not providing a lot of ideas or a lot of innovation that been developed in the Islamic world. We've got Professor Munir. He's working, but he's working in America, and the other scientists. So what we need to do about it? The second thing I learned from Professor Munir, he just told me that his son Hassan, he's working in IBM or working, sorry, with quantum computers, and he's part of the development team. I would like for this academy, please, to try to attract young people, more people who are more active in this area, and especially second and third generation of people and scientists and people who are living abroad and living outside their country and working on this science, technology, and the other stuff. So one of the things which is basically I would like to encourage the academy to do that. And at the end, I would like to basically put the stuff which I'm talking about as part of the academy, but we will talk about at the end. Let's talk about AI. I mean, AI being described by the previous two professors, and I'm going to talk about today about AI and this revolution. Where are we? Why AI is so big now? And they talk about robotics. What are we with robotics? So I'm not going to take a lot of time. I think I've got only 30 minutes. Industry 4.0 and the emergent technology. What Industry 4.0? AI, artificial intelligence, if we define it, we say is the trademark of the new world called Industry 4.0 and all the technologies behind it. AI, if I want to define it, I will say the ability of machine to do a task without human being intervention and without pre-programmed. Anything else is not AI. Anything that it could be automation, it could be any other stuff, but we will talk about it. More importantly, Industry 4.0, or when we talk about AI at the moment, we mean the whole industrial revolution or the Industry 4.0 revolution, the whole new world of science, technology, and philosophy. What do I mean by that? I'm not talking about when we say AI. AI is a trademark for that new world. It's AI trademark of the technology, AI trademark of the skill sets, and AI the trademark of the data which is using for this technology. What are the technologies which is we are looking at this moment? We're looking because it's been talked about previously this morning, but I will talk about I'll talk about technologies. What are the technologies? We start with AI, then we talk about cybersecurity, we talk about blockchain, we talk about data engineering, we talk about sensor, we talk about robotics, we talk about IoT, all and more and more and more. A blockchain, all these technologies is part of the new world called Industry 4.0 and represented by something we call it AI, artificial intelligence. So please do not be like when we look at that AI, we don't just we put ourselves in the prediction, ourselves in making like generating of data or generating of ideas or generating of picture or generating of videos. No, it is more of the whole technology from getting the data in, crushing the data and working on it. Where it's come from, I say it all the time, it came from, where is the journey came from? The journey came from all industrial revolution. Start with first industrial revolution, which is steam engine, which started here in Britain, actually started in where I am sitting here now in Liverpool, where we have the steam engine. We have more than 10 a new thing or a new ideas or new 10 innovations which is started in Liverpool. One of them is the steam engine, and we can talk about the train and the rest of the stuff. The second thing we talk about, the second industrial revolution, which is electricity, and the third one computing and computers and the rest of it. And then we have reached the fourth industrial revolution, which is automation and making intelligent decision and intelligent manufacturing. What will happen? And every single revolutions we had or industrial revolution, the world start thinking and they put a question mark. Will that affect the job market? Am I going to lose my job? And I was 2 weeks ago, I was in London with 272 medical doctors, majority of them, they were consultant. They were telling me, the young one, they were telling me, Professor Dia, are we losing our job because of robots, because of the technology? It's not really. We are going to lose 30 million traditional jobs within the next 5 years, but the world will generate 70 million jobs, but with different skill sets. What's this skill set? All the time we'll talk about the father of artificial intelligence, which is Alan Turing. Without Alan Turing in the 40s, we will never have artificial intelligence. And by the way, John McCarthy in 1956, he talked about artificial intelligence and he used the word artificial intelligence. But Alan Turing was working to break Enigma code in the Second World War. So his work was not basically given to outside to the world. Why I mention him? I mention him because of big things. Without him, it will never be able, or we will never be able to see the forgotten industrial revolution. I call it Industry 0.0, where it started in the Middle East, in Baghdad, in the House of Wisdom, with the application of zero, basically the creation of the Arabic numerical system, and more importantly, algebra and algorithm. Algorithm or al-Khwarizmi was used in the forgotten industrial revolution. It was used because of use as equation. It was used and developed a lot of the science and technology which is we have at the moment. We have a book called 1001 Islamic Innovation. You can go back to it and you will look at how House of Wisdom have contributed to the world. But more importantly, AI, artificial intelligence, was started because of Industry 4.0. It started because Alan Turing have waken up that technology or that industrial revolution which was sleeping or was forgotten. Alan Turing tried to break Enigma code, and at his time, if you want to develop anything or to solve anything and you need mechanism system, you need to develop that hardware to solve the problem. So when he was trying to break Enigma code for the German army, basically a German army was using something called Enigma code, and you need a lot of fast processing to break it. He had two things. He has diverse people working for him, from people with understand geography, history, philosophy, as well as math, physics, and the rest of the team. He has, I think, 20 or 21 different members in the team trying to break Enigma code. One of the things he did, every time he has the code, try to break it, he built a system for it, or he built a hardware for it. By the time he breaks the code, the code has changed. So I stayed between 3 to 4 months trying to think about something to do. And then he went back to Al-Khwarizmi. He went to House of Wisdom. And for Al-Khwarizmi, what he did, instead of changing the equation, he used one equation in algebra to solve a lot of problems. Then he did exactly the same. Instead of changing the hardware, he changed the software. He changed algorithms inside the software. And this is what the word algorithm came from, which is basically the basis and the foundation of all the coding and the programming, which is what we use at the moment, up to the up to the quantum computing, which is they use algorithms. So this is where they waken up the industrial revolution of the forgotten industrial revolution. Data science, I say, the heart of artificial intelligence is data science. Data science did not start just now. 1,200 years ago, we were playing around with it. And if we look at this, just one example, 1 times 8 plus 1, basically, if you look at it, and we have something called pattern recognition. Pattern recognition is the basis of what we do with AI. And if you look at it, you look at the patterns, you look from 1 to 9, you've got 8, and you've got here from 1 to 9, you've got here from 1. If you look at the next page, you will find out that the answer, it actually got patterns in it, which is 998 all the way to 987, which is, if you look at from left and right on the bottom, on the last line, you find is the same thing. Start from 1 to 9 and start from 1 to 9 in the opposite way. That means, as a human, we were working on data science 1,200 years ago, or even before that. And I can tell you something which is happening in the real world of artificial intelligence. The world of artificial intelligence is not just science. It's not just engineering. It's a philosophy. The world and people started looking at, when we start looking at the things around us, we were looking at, which is we had people in this planet, we had animals, and at the same time, we have basically plants and trees. We never had anything else. Of course, the environment around us, we start using the environment. We start using it as a philosophy. Then we change the philosophy to science, and then we change the science to applied science, and then the applied science to engineering. And this is where we had the wheel in Middle East. We created the wheel. And after that, everything created. Then we just focus on science. We focus on engineering, applied science, and we did not mix the philosophy with these things. Then artificial, or we mix it, but in very small amount. Artificial intelligence start using philosophy as part of applied science and applied engineering and pure science. And if you look at the human intelligence, we say basically human intelligence, the ability of, and defining of AI, as I said, the ability of machine to do the same thing a human being can do by doing pattern recognition, prediction, decision making, as the previous, as my colleague has said it, or my senior lecturers or my senior colleagues who just mentioned it early on in their talk. Then, what's a human intelligence? Human intelligence is the most, basically human intelligence, or human is the creation of subhanallah rabbil alameen, which we made us the most intelligent things we have in this planet. The only thing we are having now, we have people or human living in this planet, we have trees, and we have animals. Now we are going to share something, somebody else going to share this planet with us, which is basically robots. Robots is going to share our planets. And what we are doing as a human being, we are trying to make these robots or this machine to act and think like human. They can learn, they can reason, can perceive, can understand languages, and maybe they can have feeling. And that's very important, the last word. So intelligence, if we want to define it, the capacity and capability to learn and solve problems. This is what we call intelligence. With the same we have with machine. If we look at any machine, the machines, they take data in, they process the data, and they do action. From the car you go in, then what you do, you touch the car, now the car is sometimes intelligent, you touch the handle and it's open for you because it recognizes your fingerprint. Or some of the machine, even when you look at it, because it recognizes your face. You open your phone, basically your smartphone, it will open because it recognizes your face. And all that is action. Data in, if we look at it on the phone, we are just basically looking at it. It is taking your image, it recognizing your image, doing image processing. This is input data. Then action, it is basically it is comparing it to some of the vectors they have. And this is basically what is crunch data. Then the action, it is opening the phone. It's opening it for you. Are we able to have a machine to do these things? Yes, we are start doing that. But why now? Why artificial intelligence so big now? I look at every single we do these days and we just put AI to it. I look at Middle East, they are putting AI powerhouse in Middle East. It's the world, all the world putting a lot of money to have Middle East because we have sun and we have water and we can use it for basically for crunching data. Why it's happening now? Why it's so big now? Three things happen at the moment or met together: availability of data, fast machines, and the availability of a lot of algorithms made it happen. Before we did not have it. Of course, a lot of disaster bring in good things sometimes. One of the disasters we have, and one of the biggest problem we have in the last 10 years, which is we have COVID. Because of COVID, we have so much data and we start developing a lot of system to serve us. And at the same time, COVID itself, when we look at it as data, it creates something for us in terms of medicine and applied of AI in medicine. Human being, when we look at some of the symptoms and some of the diseases, we found that with COVID, different people, different race, different age, different sex, different symptoms for the same disease. Human brain could not handle it. Machine managed to handle it. And this is where the breaking through of trusting a little bit the machine. Machine start giving us patterns or giving us answer better than our human brain can do. Not they are cleverer than us, but start doing it faster than us. And this is faster that which is we needed it. Of course, as Professor Munir said early on, machine at the end of the 90s start winning against the best chess player in the world. And because they can move faster and they think a little bit in more coordinate way. And now we have machines start making pattern recognition is better. Then what types of artificial intelligence do we have? They say there are different school of thinking, but I'll narrow it to three different things. Artificial neural intelligent, or artificial general intelligent, or artificial super intelligent. Super intelligent, forget it. We are even not, we are just thinking about it. However, artificial general intelligence is here now. We start touching it now in the last 6 months or 8 months, where the machine will teach itself. It will train itself. You don't need to train it. However, the one before that, artificial narrow intelligence, where we focus on one task. For example, if we talk about generative AI, which is big, massive thing. It's happened with ChatGPT. Okay, it's big, massive things. And the people who they won the Nobel Prize. Or no, I think Professor Rahmani said it before that. They won the Nobel Prize in physics because they managed to generate a new images from the description of the image. And that's big thing. And they were basically very senior. I mean, they worked on it from 1982 about image processing. They did not reach that. Jeffrey did not reach that until 3 years ago, where John, his teacher or his supervisor, he managed at the beginning of the 90s to break through. You can get an image. I can get an image or a picture of somebody from the description from millions of images or pictures. What Jeffrey have done, from the description, he managed to get that. And that the big through by generative AI. And this is only narrow AI. So we need to train the machine. While if we look at generative AI, actually you don't need to train a machine. The machine needs to train itself. And one example of that, what we call a physical AI, where robot can move around in a room and never seen the room before or never seen a field before, but the robot can find their way and they can recognize the things around them. How can they do that? They can do that because They do statistical learning as well as symbolic learning as well as pattern recognition. And just to do a comparison between human and machine. So humans speak and listen, and you call it speech recognition, that big, massive field of engineering and science in computer science and computer engineering. A human can read and write, and we call it natural language processing with basically with robot. So much speech recognition and natural language processing are based on a statistical base. This is why I call it statistical learning. Symbolic learning, human can see, computer vision, image processing, human can do, and robotics understand the things around them. And when we talk about pattern recognition, we talked about it before, as a data science, and we've been doing it for 1,200 years. I am going faster because of the time. Okay, human brain can think and can learn. And we talk about, in one day I was talking about how people can generate new ideas, generating poems. They can do that because people, they train their neuron, and we call it a neural network. We do exactly the same with machines. And this is basically a picture. What about robots? Human versus robots. Robots are dumb, but now in the last couple of years start to becoming not dumb, start to become a little bit intelligent. So how safe they are? Question. Can this machine be trusted with delicate tasks? Can this machine one day overtake us? And what will happen? I can tell you one thing. I am training my robot, which is my robot. Basically, I call it Ami, which is basically it is the smaller version of Amica, the world's most advanced humanoid robot ready to meet humans. And when you sit next to her and talk to her, and I call her, and people laughing when I call her, because we start training her. If you want to become a medical doctor, you will take 6 years to be trained at medical school. It took me around 1 week to train Amica as to become a doctor. No, I'm talking about the knowledge and decision making and basically diagnosis of diseases. And I managed through literature by training her. I say training her. That means neuro AI, not general artificial intelligence, which is the next step. And I managed to reach her to the point that she challenged some of the doctors. And why? Because do we need doctor to memorize anything anymore? If you go to medical school, you find the first 2 years they memorize all the different things, a lot of memorization. Do we need doctor to memorize things? And that was the discussion between me and the medical doctors. And I do believe we should leave the brain of a human to innovate, like pilots in the plane. The planes now, the system in the planes so intelligent.
طيب اوكي بس مين اللي بيحدد؟ هي مشكلتي يعني كان يعني انا هسه بدي اسالك انا هلا انت لما بتعطي 15,000 من الجامعه و15,000 من المركز صح؟ هلا مجموعهم 30 انسى 30 15 مظبوط. طب الان مين اللي بيحدد انه انا بدي اصرف من ميزانيه الجامعه ولا من ميزانيه المركز؟ انا محمد اجاني اخذ دعم من المركز الوطني له تطوير 15,000. دكتور نغطيهم بموازنه المشروع المقترح المشروع انه المركز
Dr. Dia, you are muted.
Unmute, please.
I muted myself because somebody was talking. Okay. No
yes,
problem.
you are right. Yes.
Yeah. Okay.
You have 2 more minutes, sir.
How many?
2 more minutes, sir.
2 more minutes. Okay, I'll jump to the end. I was still talking to them at the end. I will use my last 2 minutes for data. Data and data set is the most important things. We're moving from normal structured data to big data, which is unstructured data. And unstructured data is good and dangerous at the same time. It's good in terms of we have availability of data that we can train our artificial intelligence with it. However, it is bad if it's missing and if it is not ethical. And there is a lot of things about data. What I would like to use my last, of course I can talk. Anyway, what I like to use my last 2 minutes is a discussion with the it's discussion with the team, especially Professor Adnan. What we would like to do, we would like the academy to be an arm of doing something which is very important. If we look at artificial intelligence and the new world depends on 3 things. Depends on technology, and now powerhouse and AI powerhouse need a lot of money, and I don't think that could happen, or it's very difficult to get involved with it, except is like, for example, in Middle East, they are spending $320 billion in Abu Dhabi to have like AI powerhouse, they call it. That's one thing. The second thing is the data, which people working on data and working on data centers. But the third things, which is, I believe as important or more important than the other 2 things, which is skill sets. What we have in the world is shortages of skills who are working in this area. What I suggest, after what I listened to the first speakers, is the academy to be involved as part of developing and training skills for Industry 4.0. Hard skills as well as soft skills. Thank you very much indeed. And if you are interested in that, I could personally involve in this. Thank you. I thought I'll give you 1 minute break for you.
Thank you.
Thank you. Thanks a lot, Professor Jumaili. Now our session, I would like to thank the 3 keynote speakers, distinguished speakers, for their very interesting talks. And I'll move now to Professor Momani, who will chair the second session. Thank you very much.
Thank you, Professor Ilyas. We will start our second session. We have 7 speakers. Each speaker will give 15 minutes only. And our first speaker is our distinguished speaker, Professor Adnan Badran. If I want to speak about His Excellency Professor Adnan Badran, then I need more than 10 minutes. So I will be short and summarize the main thing. Professor Adnan Badran earned his bachelor degree from Oklahoma State University, his master and PhD degree from Michigan State University. He is currently the chairman of Board of Trustees of the University of Jordan, president of the Islamic World Academy of Sciences, president of the Arab Academy of Sciences. He held many positions, but I would try to mention the most important. He is the former Prime Minister of Jordan, Minister of Agriculture, Minister of Education, and he's the president of several universities like Philadelphia, Petra University. He's the first and founder of Yarmouk University. He is the Assistant Director General for Science and Duty Director General of UNESCO Paris for 9 years. On the other hand, Professor Adnan is a well-known researcher. He published more than 50 books, 4 international patents, 120 papers in academic journals, 255 studies at scientific conferences in higher education. And now I will give you the floor to Professor Adnan to talk about higher education.
Yeah. Thank you, Professor Shahid Momani, and thank you, Dr. Ilyas Baidoun. And I do thank all the participants in this conference corresponding with us on Zoom. The paper I am going to present is going to be brief concerning higher education in the era of generative AI. This paper is being prepared with Dr. Professor Ilyas Baydoun and Jewel Mismar. Both are at the American University of Beirut. I asked Ilyas to present it, on my behalf and on Jewel's behalf, but he said, no, I want to relax and listen. So Professor Baydoun is going to relax and listen. Okay, I'm going to do it. Well, I think people right now, I've been meeting with my graduate students, with my students. They ask, what is the role of AI in education? Is AI going to replace the instructor? Is AI going to replace the professor? Is AI going to replace the university itself and the classroom and the laboratory? Is education in the future is going to be cyber education, where the space is the university? No more rooms like this room with windows and doors. So people are wondering, my colleague, people are wondering, where are we going? And what challenges we are going to meet? Is the future is going to continue like business as usual? Or we are going into a new era with AI? Next. Well, I'm going to present to you on behalf of my colleagues the history of AI. When and why and where did AI start? It started in 1950 in Britain. Professor Turing, Alan Turing, in 1950 published something very interesting to the world. Can machine think? Can we build machines with intelligent machines? Can machines in the future think for us or on our behalf? This paper was published in a journal, The Minds. Very few people cared about this paper because they thought his paper is a science fiction. Nobody believed it. Then a conference came out in Dartmouth about AI and machine learning, ML, by John McCarthy. And John McCarthy in 1956 raised the machine learning that we are going into a new era where machine learning is going to be influential, particularly in research and teaching and business and industry. Those two papers, the one was published by Alan Turing, became the most famous paper in the world. Citations in thousands for Alan Turing paper. And this is why I do consider him the grandfather of AI. But John McCarthy, the one who promoted Alan Turing paper. And this is why I may consider John McCarthy as not the grandfather, the father of AI. So we have grandfather and father. So we are going to talk about sons and daughters in our meeting, students and learners. If we go in this diagram from 1950 to 56, then go to 1960. In 1960, ELISA was created, and the chat pairing was created. And then in 1970, AI went into dormancy. We call it AI winter. From 1970 until 1980, AI slept, was in sleep, deep sleep, not deep learning, deep sleep, not DL, DS. So why? Because funding was very short. No funding for research, no funding for promotion, IT, and AI. However, if you look in 1990s, forget about 1970 to 1980, 1990, AI spring. AI was waking up. Why? Business, industry, and governments, they poured funds into AI research. And then all scientists, particularly in the IT or in mechatronics, went for funding. And AI started really to rise and to move. And research for business and industry has moved up. Innovation and new cognition also, and the evolution of neural networks expanded. And that was in 1990. Then in 1920, not now 210, right? 210. The AI, they call it AI boom. The AI was booming in 2010 because of funding so much, particularly from industry and business. IBM, Microsoft, Amazon, and all those giant business ITs, what I call it K-economy, knowledge economy, contributed to AI, and there was really a big data analysis and evolution of DL, deep learning. And this is where IBM and Watson came out with so much inventions in the AI space and in the AI field. Then afterward came out the launch of Dale and the Chat GPT and the Chat GPT. And this developed what I call new sites for AI, where data was analyzed and data houses were available to the AI. And then you go now to the GPT to ask him about anything. And he goes through the world databases to give you the answer and to give you the analysis in minutes. And AI now in an era which is going to influence us, which is going to really create a new classroom for our students, new learning. But what are the challenges? Are going to embrace AI, or are we going to fight AI? Or are we going to accommodate AI with us? So the robots will be our partner for the future. Is the student allowed to bring his robot with him to the classroom? How we assess students in examination, where everything is available in the cloud, and you have access to any question, you get the answer within seconds. It's going to change our type of examination, our assessment, our curriculum, because the work in the future will be with AI. And all what you need in the AI in this iPhone, put it in your pocket, you have a library walking with you. You have a knowledge house, and you have intelligence, where you ask him a question and he will give you the answer about anything, about any field, geography, demography, archaeology, science, technology, anything. So, next one. By the way, we've held the conference in Beirut. We were invited by Professor Badran, the Arab Academy of Science, and it was the subject AI. I put it in the diagram, the last one, 2025. And it was about AI in higher education. That was the theme, the title. Next one.
2 minutes.
So we become higher education in the AI era. Opportunities. What are the opportunities for educators? For educators, is education going to change the role of the teacher? Is the classroom is going to change? How the teacher is going to use the AI to assist him in his lectures? And really, how to invent interactive learning.
2 minutes.
2 minutes. Interactive learning with AI. How to create an environment of innovation with AI. And how to reduce the administrative burden in the university on the professors with AI, so they can go to more learning and teaching and research. The second thing, for learners, how to analyze academic context and how to create what I call a teaching environment with the AI. Then for institutions, is the institution going to change in the future from the current place and current conditions? How learning will be efficient from childhood and to adulthood? And that's really so many questions. How we use the data and how we mine the data for AI purpose to find the solutions. And what is the role of educator? How to facilitate critical thinking with AI, and how to create the inviting inquiry-based education, how to create an inquiry-based education with AI, how to produce what I call innovative environment and creative thinking with the AI. So many questions will be risen, and really, we don't know the answers. We don't know the answers. We are in the process of development. And this is the challenges for us in the future. It's going to change a lot of things. And the last thing, I want to shift to the last, shall we again embrace fear AI? Or shall we embrace it? Or shall we block it? Is it going to replace human intelligence? Or should we embrace the wave, understand it, and respect it, and utilize it? Artificial intelligence and human intelligence are not the same thing. Will never replace human intelligence, artificial intelligence. We are being compelled into believing that AI can replace human intelligence, when in fact the human brain cannot be fully automated. We should shift our focus on what we can automate through AI. Tools, to use it as a tool for our benefit, and really to ride the wave of research and ML, machine learning, in our development of higher education. And thank you.
Thank you, Professor Adnan, for this interesting lecture. I think it should be a keynote lecture, keynote speaker. Now, our next speaker is Professor Zepta Shinawat. Professor Zepta is a fellow of IAS, UNESCO laureate, Vice President, AIS Distinguished National Professor, Professor Emeritus, Vice Chancellor of Federal or the University of Arts and of Science and Technology in Islamabad, Pakistan. He published many books, many research papers, many citations, and he received many awards. The floor is yours, Professor Zepta.
Thank you very much, His Excellency. First of all, I'm really grateful to our President, Adnan Badran, His Excellency, and all the team of IAS for inviting us for this. What I'm going to talk to you all is, I hope you can see my slides. So about the ethical governance of these frontier technologies, what we call it, AI and nanotechnology, specifically in low and middle income countries. How can this be really, has an impact on our society? So first of all, when we say these two, AI and nanotechnology, this is sort of transformative technologies in our time. Because AI is revolutionizing the data analysis, automation, decision making, etc. As we are listening since morning, excellent presentation by Professor Adnan Badran. Thanks for Ilyas Badoun also for having all this interaction. And the nanotechnology, when we talk about the various modern things that we deal with the atomic and molecular scale for medicine, material, etc. So the nexus of both of them promises unprecedented advancement. So we have to, we can have targeted drug delivery, we can have intelligent nanomaterials, etc. But the imperatives of all this is that this is reshaping the society. This is, of course, ensuring the development, but at the same time, the development should be ethical, equitable, inclusive, specifically for the most vulnerable population, and that is in the low and middle income countries that they are facing. So if we talk about the ethical principles, we may come across several. You all know about it, from autonomy to beneficence to non-maleficence to justice to veracity to fidelity to confidentiality to respect of an individual human being, to have integrity for all the data, etc., sharing all that, to have accountability if something happens because of the data, the privacy, other things, and the transparency of sharing all this information with the community, whether it's a medical profession, whether it is, safe city projects, whether your privacy is at stake. Then we can also talk about utility. When we talk about utilitarianism, that the outcome of a technology, if it is good for the humanity, not only humanity but biodiversity, we call it One Health, biodiversity, human and environment. So that all, what is the outcome of all these two disciplines that we are talking about? So, and finally, whoever scientist is working on this, the virtues that they have, that the cultivation of virtues like honesty, courage, and compassion in our young population. So these are the principles, ethical principles, that when we talk about, modern technologies, we have to keep in mind these basic principles of to have an ethical outfit of it. So, what are the challenges when we talk about ethical dilemmas? That is, the first of all, data privacy and security. The vulnerable population, the less educated population, specifically in the low and middle income countries, in the Muslim countries, a lot of them, they even can't read and write. 60% of people sometimes in some countries like in Pakistan. So this data protection and then misuse of the data, not only the data but the human parts like blood information, genetic information, and other information. And then algorithm biases and discrimination. They are sometimes designed in such a way that they are discriminated the populations. Equity of access and benefit sharing. This is mainly in the developed world that they are getting all the benefits of things. So the access to majority of the population is really difficult in that. As I said earlier, accountability and transparency. Who will be responsible when AI-powered nano systems have some harm to the individual or to the population, especially across the borders? So, and then finally, we had a recently meeting on synthetic biology, introduction in the biodiversity. So that, like, how can they deal with it? So when we say equity and equality, let's have a reality check of the global divide. When you look at the disparity in R&D investment of the developing country, in the low and middle income countries, 0.4 trillion US dollar in the whole low and middle income country. While if you look at the high income countries, it is almost 3 trillion US dollar. And then the whole data that is generated, if you look at the low and middle income country, it is somewhere around 10%. Rest everything is with the developed world. So there is, when you talk about the WIPO, World Intellectual Organization, R&D, the UNESCO report says that the control mainly of all this is with the developed world. So there is that we all as a Muslim world and low and middle income country has to work on it. And this results, when the data is when the information is mainly with the developed world, that results in the brain drain. Some people very, proudly says, oh, we are getting dollars, our population is sending dollar back. But that is that your most intelligent brains goes outside. And then regulatory lag, slower development of specifically in the poor countries, the ethical principle, regulatory framework is really difficult to establish. And the prioritization of challenges that we face in the developing world, the governance, etc., has to work on it. So for this, the ethical imperatives in these countries, the basic few of them that some of them I mentioned, like data privacy, security, algorithm, equity and benefit sharing, accountability, etc., environmental impact, and dual use concern. These are the things that we all have to work on it. So, for equitable governance, these are the four pillars for it that you have to ensure: capacity building and education across the country, not only the capitals of the country, like in Islamabad, for example, or Lahore, or 3-4 cities in Pakistan, for example, or Jordan. So then you have to take it to the countryside. Policy localization. We have our own culture, religion. So we cannot adopt policy from the West as such. We should localize policy for our people also. Multi-stakeholder collaboration. We have to work with the. We are saying this is a buzzword, DNA, government, academia, and industry. But in reality, it's really very difficult in the developed world. And then, of course, South-South cooperation. We should be helping each other in all this. So, let's go from global norms to the local relevance. First, ethical pluralism and cultural contest. This I'm talking about the Islamic World Academy of Sciences. We are Muslims. We have our own, culture that we have. So, ethics is not something that fits everywhere. It's not common for every human being. We have our own principle. So that is that we have to ensure our principles in our system, equitable inclusiveness, governance, etc., and the need of diverse ethical frameworks for different kind of population, etc. Indigenous, religious, and local philosophies matter. Because for us, Islamic ethics, and for example, for Muslim countries, for African Ubuntu, for example, South Asian philosophies, for example. So these are all that we have to consider when we talk about ethics in AI and nanotechnology. And we have to avoid Western-centric models of governance. We cannot import it as such for ourselves. We have to modify it according to our needs. So, finally, then what we need? Pathway for the progress. First of all, international bodies like UNESCO. I was the co-chair of World Commission for Ethics in Science and Technology. We developed some norms for the global things. We facilitated dialogue in many countries. We built capacity of the people in the third world countries, or you call it low and middle income countries. Knowledge we shared, and we did advocacy for all these modern technologies. And the opportunities are, of course, there, like AI for health in Africa, for example, AI in agriculture, for example. You can predict climate change now very quickly. You can understand Pakistan is still suffering from floods every year. But we still, we go and, distribute some food there and that's it. But we are not planning for our future. And the digital literacy, of course, at the grassroots level, to educate the communities, indigenous people, etc. We have to work on that. So recommendation and call of action for all of us, that is prioritizing ethical infrastructure, specifically IAS can lead on this, foster interdisciplinary research. We should encourage them to work together and develop context-specific guidelines for all the people that work on it. And we have to have advocacy for the global equity in the developed world. Our friends are there. We should take help from all of them and empower local voices. Encourage the people to speak to your younger generation. So now translating global standard, they are there, into local action. What we need to do is that we have to implement some of the recommendation modified, according to our need and culture. We have to co-create local ethical charters for our own countries, for our own population. And we engage communities in dialogues. We talk to them, we guide them as to what happens with the social media, for example, with the now mobiles, and even in the war. You saw in Lebanon what happened with the pagers, for example. So these are the things that we have to work on it. And the take-home message from my side would be a shared responsibility for us, the Academy of Sciences, Islamic World Academy of Sciences. We have to make some kind of, governance system of AI and nanotechnology. We share the responsibility. We bridge the global divide. Is not merely an act of solidarity. We need to work with them, and we have to work together to co-create our future for all of us, and then adopt a model for AI and nanotechnology ethics similar to climate governance, for example, where carbon credit and other things are there. So these are the few things that we all need to work together for this. So future course of action, and that is that we continue advocacy, AI nanotechnology policies. We strengthen partnership, not only within the country for academia, industry, and civil society, but also among our countries, Islamic World Academy of Sciences. We have submitted a project. Maybe today we are talking in our council. We may be working on this and expand capacity building initiatives and foster ongoing dialogue to integrate diverse cultural perspective, ethical framework. And the end, let me thank our mentor, Adnan, Badran, Ilyas Baidoun, and all other friends, and specifically our staff at Islamic World Academy of Sciences. They had a wonderful kind of arrangement. I'm really grateful to all of us and all the speakers too. I learned a lot from today. Since morning, I am listening to all of you. Thank you, ladies and gentlemen.
Thank you very much, Professor Zetta. Our third distinguished speaker is Professor Noor Bhatt. Professor Noor Bhatt is the Bristol Professor and the founding chairman at the Bristol Institute of Nanoscience and Technology at the Bristol University, founded in 2010. This institute in Pakistan, probably in the OIC countries, to award the multidisciplinary BSc degree in nanoscience and nanotechnology degree. So the floor is yours, Professor Noor. Professor Noor, can you hear me?
Yes.
Okay.
Can you hear me, please?
Yes, please.
And my slide is visible?
Yes.
Okay, thank you very much. Let me first, Bismillah-ar-Rahman-ar-Rahim. I'm very glad to acknowledge the help of my great friend, Professor Badran, to invite me to this meeting. And I will be very short, and a lot has been said very elegantly by Professor Atta-Ur-Rahman, who was the main supporter of the nanotechnology in Pakistan. Just before starting, I relate one story about Professor Atta-Ur-Rahman. In 1995, I gave the first lecture in introducing nanotechnology in Pakistan in a lecture at my institute at Nuclear Science. And in 2002, there was a conference in Islamabad of the Islamic Academy of Sciences, and there I presented an overview of the nanotechnology for the first time. Professor Atta-Ur-Rahman picked that up, and in 2003, he asked me to prepare a program for nanotechnology in Pakistan. And within a week, he wanted this. So I did it with the help of my younger colleague. And we were traveling. The interesting point is we were traveling from Islamabad to Karachi in a plane. Just by chance, I didn't know that he was. And a few minutes before I came to know of him, and I took that project with me and gave it to him in Islamabad. And by the time in 2 hours, we got down in Karachi, he had all the different suggestions written on it, and I've got a copy of it. So that is his way of working, and all through, he managed to support this nanotechnology in Pakistan. I'm very grateful to him for all this little work which we are able to do. And now in Pakistan, all universities are involved in nanotechnology through that initiative. So now let me go to my topic of nanotechnology and its nexus to artificial intelligence and their necessary interdependence, on which I will put my stress. So this is the scheme of presentation, and I've introduced very quickly my institute. This is the Nuclear Institute, where I spent about 35 years of my life. And in the beginning, the nanotechnology was difficult to define. A lot of new words were coming up, and in 2009, I simply, for my sake, made it as a study in manipulation, control, and use of nanomaterials and their structures. That's important at the nanoscale. So this was the definition. I quickly, because I don't need to go into details which so elegantly have been done by Professor Atta-Ur-Rahman, and I go right quickly to one of the clarification that although Feynman in 1959 had laid the foundations of the atomic manipulation at atomic level, but the word nanotechnology was used by Professor Norio Taniguchi in his 1974 paper for the first time, while he was a transistor scientist. So I'll go on to the applications of nanotechnology. As you know, is all industries are involved, and some people have estimated from the National Science Foundation of United States and other places some $3 trillion marketing of the nano products. That's the huge economic aspect, and the global impact was there in the form as an industrial revolution. And nanotechnology, along with the artificial intelligence and other quantum computer, etc., other factors, is part of the fourth industrial revolution. So that's the other things which are involved in the revolution of the technology. So I'll concentrate simply on the nanotechnology and artificial intelligence, and particularly differing from other contents which have been elegantly done by the previous professors, Atta-Ur-Rahman and Nayfeh. I will discuss the applications of nanotechnology and artificial intelligence in the field of nuclear and air defense, very critical parts where it is important to consider how to use the nano technology and artificial intelligence. So I'll go straight to the, already these two aspects have been said, that the nanotechnology involves the surface to volume ratio is the important part, a scientific point of view, and at that scale, the bulk properties and nano size properties of materials differ very much. That's the crux of it. Now, I come to the main topic of today, which in the next few minutes I'll discuss, and that's the artificial intelligence and nanotechnology interdependence. That's very important. Although the AI are closely connected and their integration has created new areas of research known as a topic as AI nanotechnology, is the term now being used. And AI plays a key role in the nanotechnology in a number of ways. So as has been explained by the previous speakers. What is AI? About extracting value of data. So that is important, I think, to understand that it is a data analysis which helps a lot, of course, in many fields as has been discussed. But what is important is that in critical fields where a lot of precision is needed and where irreversible and irreparable loss can occur, we have to be very careful in the application of nanotechnology. And that two areas are nuclear and air defense, which I will talk about, and some of the benefits and limitations of AI in these two fields. So apart from the variety of applications, it is important utilizing AI and its subsets, machine learning and deep learning, as has been explained already. Now, what are the benefits and risks involved? The benefits of the AI in combination with the nanotechnology offers the significant potential for nuclear science and technology, of course, to some extent. But that benefit has to be carefully limited to the risks involved and to make careful study before using it for these two areas. And the serious risks are in cybersecurity, reliability, and misuse of nuclear weapons. And what are the potential benefits? There are listed quite a few: enhanced safety and reliability in the nuclear field, improved efficiency, advanced nuclear security, accelerated research and development, optimized medicine.
Did you change the slide, or you still have the first one?
Today is not available.
We have the first slide only.
Oh, I see. Change नहीं हो रहा। 2 मिनट पीछे जाओ। चलिए बस। Are you seeing it new ones?
No, not yet.
Can you see the new?
No,
Can you
we
see it
can-
now?
Maybe you have to stop sharing and do the sharing again.
خلاص, maybe he has to say. Thank you. Yeah.
Can you hear us, Professor Noor? Oh, okay, has to, okay.
هذا نزعنا البرنامج.
Yes, you can go to which slide you like.
The last one.
Can we go to the I think I can go without slides what I want to say.
Okay, doctor, please. Yes.
Is it okay?
Yes, okay.
Okay. So now I was discussing some benefits of the AI in the nuclear field, and there are quite a few in making it fast and efficient to some extent. But what is important is to how much we can go about, because we cannot take the risk of having a false calculation of because the AI helps in the data analysis. If the data is not very accurate, we cannot take the risk of attending. Usually in all experimental sciences, we have to first be careful, particularly nuclear and the air defense systems. We have to first do the experiments on the ground or in the lab, and then be sure that it works in the larger scale. So in the situation of atomic weapons or so, we cannot take just a simple design which is not very accurate and has some errors which are not suitable for launching it. Therefore, I think in addition to the benefits, we can go to the risks which are involved and be very careful in application. Now, this is what my concern is about the use of very useful AI in many areas, but in the nuclear and air defense, we have to be very careful. The second aspect which I wanted to highlight in my talk was the educational aspect of nanotechnology, which is something different from the previous workers. Although Professor Badran has very elegantly expressed the AI applications in education as a whole, but I am concerned with the real education at the undergraduate level. That means 16-year education. So that's the sort of area which I'm concerned with. In our 10 years program at the Preston University, we launched a multidisciplinary BS program, that means 16-year education, with 4 major subjects: physics, chemistry, biology, and material science at a multidisciplinary degree. And that was the only one in Pakistan. And in 10 years' time, we produced about 65 graduates of this type. And the result was that this degree has been appreciated very much abroad, in the sense that out of 65 graduates we produced of this multidisciplinary degree, 40 of them been able to get fully funded scholarships of MS and PhD level in 14 countries, which is, I think, a very rare example of getting foreign funding from other places for higher education. like MS and PhD. So this is, I think, two aspects of my talk, which I wanted to introduce. The nanotechnology application with Nexus of artificial intelligence is important, but to summarize, but in the fields of applications of nuclear science and air defense, it is very important to see what risks are involved in the accuracy of the data of calculation of AI. The second is about this education aspect of at a BS level, which is very important to the entry to the higher research, to the jobs creation, and so on. Therefore, this grounding at this level of the nanotechnology and AI is very important. So finally, the aspect of introducing multidisciplinary courses. In addition to the 4 subjects, I suggest that we should introduce the AI courses also, along with some social sciences, because society has to accept what we do, produce our new research in using the artificial intelligence. So therefore, this is important that these 2 additional subjects, along with the subjects of 4 subjects which we have so that's all the 2 things I wanted to say. And the last, I think, although AI helps in designing of the systems, but it is a theory, and a theory is accepted only when the experiment proves it. This is even so in case of award of Nobel Prizes. I can give several examples. One very recent one is that of the Higgs particles in physics. They were proposed in 1964 and verified in 2012, and the Nobel Prize 2013. So that was the delay from 64 onwards to so much. So with all this brief introduction on the applications of nanotechnology with AI in the nuclear and defense field, I thank you very much, and thank you for listening to me. I'm sorry for this internet interference sometimes which happens. So kind of you.
Thank you, Professor. Thank you, Professor Anwar. Our next distinguished speaker is Professor Malik. Our next speaker is Professor Malik Ma'za. Professor Malik Ma'za is a fellow of the Islamic World Academy of Sciences, UNESCO UNISA Africa Chair in Nanosciences and Nanotechnology. He has a huge number of publications, a huge number of citations, and H.R.H. So the floor is yours, Professor Malik. Can you hear me, Professor Malik?
I hear you very well. Thank you so much.
Okay.
I do apologize. Do you see my slides?
No, we cannot see any slide now.
Well, I'm supposed. Do you see them?
Yes.
Are they?
No. Yes. No. Yes. Okay.
Are they moving?
Yes.
Thank you. First of all, بسم الله الرحمن الرحيم والصلاة والسلام على أشرف المرسلين سيدنا محمد رسول الله والصلاة والسلام على كل الأنبياء أنبياء رب العالمين ملك العرش العظيم. أما بعد, Honorable President, Honorable members of the Council of the Islamic Academy of Science, senior members and junior members, and all participants here, and members of indeed of the directorate of the Academy. I wish to express my gratitude first to each and all of you, and to our president in particular for his invitation in sharing with us and for involving us in this endeavor. While my different colleagues who have spoken in a very with a very insightful, comprehensive contribution towards artificial intelligence and nanosciences and nanotechnology that would definitely move on their pathway and follow their footprint. I would like just to stress on the fact that I will be giving some typical examples that at our level we have embarked in while using artificial intelligence, machine learning, data mining, and computational in the field of nanosciences and nanotechnology to address a number of potential challenges that are within the health, energy, and water sector. Nexus, sorry. The field of nanosciences and nanotechnology, by the way, just before starting, I was just to mention that once the ethical aspect are dealt with, artificial intelligence and machine learning, data mining, and computational are conjugated to nanosciences and nanotechnologies are outstanding tools to advance not only knowledge production, but to address the societal challenges in the water, health and energy, and food security nexus. In the field of nanosciences, it was just natural that it will be linked straightforward to artificial intelligence and all the domains which are related to it, because by nature, nanosciences and nanotechnology is multidisciplinary. It is at the edge, at the interface between different disciplines, as well as it creates bridges between different disciplines. Yes, indeed, it is material sciences based or core component is material science, but nonetheless we use extensive amount of computational components to validate and engineer materials at the nanoscales for applications in chemistry, in engineering, in environment, in the agri sector, as well as of course in the health sector. But initially it was mainly linked to physics. Well, in terms of investment worldwide, the early stage in the 90s, it was dominated by mainly the USA, but from 2000, quite a larger amount of nations and international agencies have embarked in. And in that regard, as you can see, this is investment as you can see here, in reaching billions here. It was dominated by mainly advanced nations, of course, but in the rest of the world, it was extremely very low. But nonetheless, as it was pointed out by Honorable Professor Atta-Ur-Rahman, when you bring that to the per capita and per GDP, a number of countries in the South have really overperformed within the years, yet with the limited budgets. Just to give more or less correct one more or less description, as more or less it was mentioned by Professor Atta-Ur-Rahman, if we have to bring the output of publication in the field of nanosciences and nanotechnology, that is publications, scientific reports, patents, and so on, if we bring them per GDP in terms of article by billions invested, it happens that a number of Muslim countries are among the top ones. And in effect, the top one who is producing so much per GDP per capita is Iran, number one. And as you can see, quite a number of also Muslim countries are among the top ones. How can I say? And well, as it was mentioned also by one of the honorable speakers, it was absolutely right not to forget Al-Khwarizmi, who brought the 1 and the 0, which is the base core component of any artificial intelligence or any, how can I say, current and future algorithm. In addition to that, this was in the past, but nonetheless, in the recent year, the Nobel Committee has indeed also recognized the impact of a number of members of the diaspora. Munjiba Wendi from MIT as a Nobel laureate for his discovery of quantum dots in 2023, and recently this year, Professor Amar Yagi in 2025, sorry, there was a mistake, for his discovery of completely a new type of chemical compounds that is metal organic frameworks. And of course, we should not forget how can I say, Professor Atta-Ur-Rahman is really one of the top scientists in the field of chemistry specifically, and one of the unique fellow of the Royal Society from the Islamic world since 2006. That is said, colleagues, that therefore the Islamic community is not poor in terms of expertise and vision in the field of nanosciences and nanotechnology. I think we should build on it and cement the impact via the academy and via all other partner institutions to the academy. What is sure is that the combination of artificial intelligence, machine learning, data mining, and nanosciences and nanotechnology would definitely be an outstanding facilitator and a bridge to address a number of sustainable development goals in that regard. And in this regard, colleagues, I would like just to share with you some of them, whereby we, from the South African side point of view, with our colleagues from different parts of the African continent, as well as the Middle East, specifically Iran and Pakistan, we came with a number of potential solutions in that regard. If we have had to take the Mendeleev table and to try to innovate and fabricate or engineer materials with the specific functionality, but in a cost-effective way, because we do not have the financial resources. So we have to count on how can I say, machine learning, data mining specifically, to identify the, how can I say, identify the path that we have to be following to identify and synthesize, engineer that material and test it correctly, as it was mentioned by Professor Anambat, to test it in the experimental lab and take it from the lab to the society. If we have to do that in the standard way, without resources, financial and infrastructure, it will be impossible, because from the 63 elements in the Mendeleev table, it will take years to identify a material, for example, who could catch arsenic and remove arsenic from the water, or something, a material which would allow us to, how can I say, to be able to find a solution for the diabetic wound healing, for example. So in that regard, data mining, machine learning, combined with the nanosciences and nanotechnology approaches, allows us to gain not only from the financial side, but also to gain in terms of time to reach a potential solution. And in that regard, colleagues, I would like just to share you some typical examples, one which is related to health. Well, colleagues, you know that this is more or less the red spots. It's the regions where the arsenic is heavily contaminating the water resources, specifically the groundwater. As you can see, colleagues, Asia is really heavily concerned, but not only Asia, Africa, but Europe and the US and Latin America. There are solutions, but they are expensive for us in life. For example, in Bangladesh, it is impossible to use these highly advanced, non-cost-effective technologies to remove arsenic from the groundwater. for drinking water. So we have had to come with, and using data mining in particular and machine learning, it was possible to identify some specific family of materials that we should focus on, and therefore taking once we are guided by that, we have indeed used the CHPC, that is the center of that's the center of high performance computational capabilities, to identify the correct material. And once we have identified it, we have synthesized it, as you can see here. I will not be able to give you the exact name, please. It's under patent, but I do certainly apologize. Once the patent is granted, there will be a full description, which will be and publication sent to, of course, our Journal of the Academy.
Professor,
Our news.
you have 2
Yes.
minutes. You have 2 minutes.
Okay. So this technology has allowed the combination of machine learning, data mining, and nanotechnology has allowed us to to identify this material, and this material indeed is capable to remove arsenic from contaminated water, to reach levels which are far below the World Health Organization limit in terms of health hazard. Colleagues, because time limitation, I just cannot go for. What is sure is that I will share the presentation with the colleagues of the Academy. The case that I would like just to share with you is how can we use machine learning and data mining conjugated to nanosciences to address this problem of carbon footprint. As you are aware, this is the carbon emission per capita per country, colleagues. And as you can see, the Middle East is quite a heavy emitter, with a number of other countries, colleagues. What is sure is that the data mining and machine learning has allowed us to identify a specific type of materials, and that is the coral, the conversion of CO2 to coral. And that means conversion of CO2 to calcium carbonate. And it is in this regard that we have managed indeed in a very limited short period of time to be able to demonstrate and validate the conversion of CO2 to a carbonate. And this carbonate here is a very effective as a nanofertilizer, as how can I say, confirmed in different countries, in China, Canada, Sweden, and Pakistan, whereby clearly we have showed that this carbonate, nanoscaled carbonate, are very effective fertilizers. They can be used at a small amount, but the result is outstanding. They are biocompatible and so on. So I was just to mention that artificial intelligence, machine learning, and high computational performance capabilities have some negative aspect on the society. They are energy hungry. They consume a huge amount of energy, and they use a huge amount of water for cooling. Just, dear Chair, please allow me just to share this slide here, and I will end my presentation. What is sure, colleagues, data centers, as you can see, they consume huge amount of energy. That energy consumed by data centers can be higher than the full energy consumed by some countries, if you take these countries, for example. So it is of a concern that the energy consumed by data centers, which are necessary to machine learning and artificial intelligence, and that this would certainly oblige us each and all artificial companies involved in this field to embark in building their own nuclear reactors to how can I say, to respond to their energy demand. And the other thing, colleagues, is that nonetheless, with this negative aspect of a huge energy consumption as well as water consumption, it is certainly sure that the field of nanosciences and nanotechnology using machine learning, data mining, would be able to allow the South countries to come with nano solution to address their problems. Thank you so much, colleagues. Shukran jazilan.
Thank you, Sir Malik, for this interesting lecture. And our next speaker is Professor Hala El-Hassan, a fellow of IAS. She is serving as a distinguished professor at the Electrical Engineering and Smart System Department at Islamic University of Gaza. Also, she is a research visitor at the Department of Materials at the Imperial College London in UK. She has many awards, many citations, and she has many positions in her career. Now the floor is yours, Professor Hala. You have 15 minutes. Professor Hala, are you with me?
Hala.
Yes. Gaza.
Yes, I'm from, hello, yes. Assalamu alaikum.
Alaykum assalam.
Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. I would like to thank the organizers of the conference, all my colleagues, for giving me the chance to give my presentation. I think you can, as I have been introduced, I'm from Gaza, and Gaza is a small place, and Gaza Strip is a small place which has 41 kilometer long, between 6 to 12 kilometer wide, with a total of 360 square kilometer and around 2.5 million inhabitants. I wanted to show this link. I hope it will work. I think I have to stop. It doesn't matter. Just to show the importance of to solve the problem of electricity in Gaza. I don't know how, it doesn't really work, but it's okay, no problem. It's just a video which shows what's happening to the electricity in Gaza before the war, before the genocide, and after the genocide. So my presentation will talk first about the crisis in Gaza, the energy crisis, and then I will go about how to solve it using renewable energy sources, using hybrid system, and what is the role of artificial intelligence in this issue, and some conclusion. So Gaza is suffering from electricity problem. So the demand in Gaza is around 550 megawatt, but only 50% available, which is actually comes from fragile sources, which is mainly the one power plant in Gaza, which had been bombed during the war, and or the genocide, the better word. And some we purchase from Egypt and Israel. So, and it's heavily dependent on the fossil fuel, as well as it has a problem with the infrastructure damages all the time. This electricity outages cascade into other critical services like healthcare, water, desalination, plumbing, sanitation, etc. And so we have a very complex system with a highly demand supply, highly variable demands, damaged infrastructure, data scarcity, external disruptions all the time. That's exactly a linked domain where advanced modeling, forecasting, optimization can have a high value, like using AI. So Gaza, why we think about going to hybrid energy where we have renewable energy sources? Gaza is really rich with renewable energy sources. For example, she's in the hot belt where it has a high solar irradiance. So it has almost 300 sunshine days, annual global horizontal irradiance around 2,000 kilowatt hour per meter square. The wind potential is very high also. Where we have, I mean, it's not really high like the windy places in the north, but we have like a potential to have wind energy in the southern part of Gaza, in Rafah. And so also we also have sources for biomasses. We have a lot of sewage, we have a lot of results from the olive trees, and currently we have a lot of damages and a lot of bio residues. Also, there is a high impact with using hydrokinetic energy. We are on the shore of the Mediterranean Sea, and there are some projects have been run and during the calm times in Gaza, where professors did some experiments to see how much we can get benefit from hydrokinetic energy. Also, there is a potential to use geothermal resources. So eventually, we have a good combination of different sources of renewable energy. So we can use solar energy, wind energy, biomasses, geothermal, hydrokinetic, but how much percent of each one? It's apparent that we have a lot of potential from PV, maybe biomass, more than wind and geothermal and hydrokinetic. So we used a program called HOMER. And this program works to optimize the system and find out what is the best combination of all these sources of energy, so we can get to supply the enough load which is demanded by Gaza. And HOMER import data about, for example, solar irradiance, wind speed from NASA, but the rest we have to feed to the program, like how much we have biomasses, geothermal, hydrokinetics. So the system looks like that with HOMER. It's a multiple renewable energy sourcing, and by the optimization system of HOMER, it was suggested that the system shouldn't be off the grid; it should be on the grid. So in most of the case, which also very good for us, because once we succeed to make such a system, we will be able to cover the load and also sell to the grid. And so the total AC load is 3.09 terawatt hour per year, and we will sell to the grid around 3.43 terawatt hour per year, and there is an excess energy of 907 gigawatt hour per year. So the cost of the system is not cheap. It's reached about $2.86 billion. And however, the levelized cost of energy, which is the way we use to optimize the system using HOMER, so we wanted the lowest cost of energy, which is what is the customs will pay. So it's around 0.034 kilo per kilowatt hour in dollar unit. And however, the system will get payback in 6 years. He will return all the investment. So why we? So I think there's the missing that. Anyway, why we need the AI? We said it's a very complex system. It's rely about many things. For example, out of destruction, security of data, and all the time there is a lot of changes. So we really need to depend on AI. For example, forecasting and optimization, reliability and cost reduction, and also statistical support under crisis. So it also helped to improve production accuracy and also boost the PV scheduling and stability. So that's for the AI part for using PV. For the wind, I'm sorry, I don't know what's happened to the title. AI for the wind part, we need it for prediction of the wind speed and also to monitor the turbine health. Everybody knows that wind blades are very expensive, so it could be affected by many things like wind or maybe by birds who passing through. So it might have some problems, some cracks. So there should be a monitoring for the system to decrease the damages or to catch the damages before it's happened to or become catastrophe. The same thing for the BVs. Of course, we need to detect what is the problem with the BVs before they accelerate. For example, we need some way to get rid from the dust. And this is also has a very important part in research in nanotechnology. So out of nanotechnology, researchers try to implement some a new layer above the PV cells. So it will either eat the dust or use the dust as an absorbent layer. So it could be a useful layer instead of being a harmful layer. So nanotechnology now is working in this regard, which is very important for areas like my area and very dusty areas like Kuwait and Saudi. And the same thing for wind turbines. It's very important to keep monitoring the system. It's again also for forecastings and and for fault detection and adaptive control. For biosystems, we need AI to predict raw materials. Also, we needed to reduce downtime, increase the renewable share, enhance reliability, optimize dispatch, reduce excess energy waste, and simulations for resilience and real-time control decisions. So also we need AI to support planning and incentives, smart infrastructure deployment. And also it's very important to use AI and renewable energy because, for example, in our system, we found by using the renewable energy sources that we can reduce the release of CO2 to around 50%. So it's to give us a clean energy and resilient supply. It's also very important to think about it because I don't want to talk about the situation in Gaza, but you know that is a lot of problems and there's a loss of jobs. So having this system also will create a job market for the youth, especially for the youth, and it will reduce our dependence on the external energy sources. Like, as I said in the beginning, we buy energy from Israel, Egypt, and our one local plant is mainly damaged by the Israeli most of the time. So it will be reducing the dependency on the grid also of the external energy sources. And so it will help us to, so AI is very important because it will help us in this system, which is, as I mentioned in the beginning, we have a data scarcity. And also it's very important for cybersecurity. And also it helps to decline the cost and the training needs. So in conclusion, AI enables optimized hybrid renewable energy system, as example in Gaza Strip, which is in need. It's to provide a better cost, stability, and sustainability. So what is my recommendation is to help to rebuild a new energy system depending on renewable energy for Gaza Strip. Invest in AI enhanced forecasting and optimization to improve electricity availability and to protect essential services in the system for Gaza Strip. And it's AI also used. It's very important to use AI in the system to make a grid analytics to accelerate damage assessment and guide effective construction of Gaza power station. And thank you.
Thank you very much. Thank you, Professor Harra, for this interesting talk. And our next speaker, I think Dr. Farhan Jalis is not available, so we move to the final speaker, Professor Mohammed Nawaz. Professor Mohammed Nawaz is a professor of mechanical and industrial engineer. He has more than 45 years of academic and administrative experience in higher education institutions in Pakistan and Australia. He is well known for his pioneer work, algorithm, and H.R.H. Nawaz score Aham algorithm. So the floor is yours, Dr. Muhammad. So please.
Assalamu alaikum.
Alaikum salam.
Can you hear me now?
Yes, please.
And can you see my presentation, please?
Yes.
Okay. First of all, I just say thank you for Professor Badran and Professor Mumani giving me opportunity to talk about my work. Now, this algorithm is very old, but if you look at this here is 1 minute. It is relevant now, it was relevant in the past, and it is going to be relevant for for many years. What is in this new algorithm? It is the name that is given. It is Nawaz and Score Ham algorithm. It was not my name. It is not given to me myself. It is the people who have used this algorithm, and they call this Nawaz and Score algorithm. Now, but first thing is presentations. In the morning, we listen to so many presentations. All talk about is AI, and some people mentioned about Industry 4, about data processing and all things. The Nawaz L-score algorithm is what? It is about data processing. And the people say this data processing is a fuel for all AI. And Nawaz and score Ham algorithm will help you efficient scheduling of jobs and computational tasks. What did this mean actually? I'll come to this one in a minute later. Now, if you just go to Google search, you can find all the information about the algorithm. If you just say this NEH algorithm, and you will find this is on your laptop or your computer or anything, just type in Nawaz and score algorithm, or just simply NEH algorithm, and the algorithm is already there. Now, but just a bit one. What is this algorithm? It is about scheduling of jobs or tasks. And the task could be anything. It could be product in a manufacturing, it could be customer, it could be aircraft, landing on the plane and things like that. Or it is about data processing, or it's about data. Now, when you could see a job, the problem is about the sequences of jobs. If you have only one job, there is no question about making decisions. But if you have two jobs, then there are two possible sequences there. That is job 1 and job 2, or job 2 and 1. But if you have 3, then you have 6 possible sequences. If you have 4, it is 4 factorial, which is 24. And if you have, let's say now, 50 jobs, look and see how many jobs or how many possible sequences there. So the best sequence, find out that is very, very difficult to find. So it is not, it is the job, this scheduling is hard problem. Now, my old publication or the paper that was published in 1983. And this is my name, Nawaz, and score was my first supervisor, and Youngham was my second supervisor. When the paper was published, it came, you see these names, Nawaz, and score and Ham, and Nawaz is, look at it's application that is Nawaz, Pakistan. So it is basically, it is a Muslim or from Islamic world. Now, what is this Nawaz algorithm? It is, instead of having, say, n factorial possible feasible sequences, we will look at only this much number of feasible sequences, and you can find the optimal good solution. It will not give the optimal solution, but it will give a very, very good solution. Now, look at, see, this is n factorial is 1 times this, all this is, whereas in my case, it looks as only a small number. This is a constructive algorithm that is going to be step by step. See, there are 2 steps. Just find, you see this one, that is initial order, and then insert jobs one by one at a time. So that's the only thing, that is solution. Or just make it a bit more complicated, see this a bit, see, phase. This is step 1. Step 2, have you see go to, and then goes to 30, you see stops again. So it is nothing matter. Look at this now. If you have, you see, let's say suppose 20 jobs, I look at only 210 sequences, and if you compare this one is 20 factorial, which is 2.4 times to the power of 18. So very, very small number of jobs are evaluated or sequences evaluated, and you can get the solution. And the solution is so quick, and you get the result you get is this one. So this is the same thing I gave you before that one. If you just go to this Google and type in, you see H.R.H algorithm, and you will find, you see, what is that. Now, this is, you see, just see it's code, very, very simple code. This is very simple, this one. Now, if you look at it, see, it is citations. It is just one job. I'm talking about one paper. It's more than 3,000 citations for Google, or Scopus is this one and this one. So not many paper from Islamic world has so many citations for, I'm talking about paper, not paper, you see, citation of researchers. It is just the paper, this one. Look at, you see this one. It is more than 24 years old, and still you see gets about 150 citations a year. And it will continue like this one. Now, another thing is looking at the citations. Citations are not just the background ones. It is the method itself. That's the main thing, which is, you see, why the people are looking at, see, this one, how to apply, you see, this algorithm to in different areas. Now, the people have, you see, check, you see, this one, whether you see this, you see, a good result gets to be 1990, and the paper, you see, compare, you see, this one, all algorithm available at the time, and find this is the best. Look at, see, the result. That is almost, you see, 96% close to the optimal. Look at, see, this one. So only, you see, very small percentage of sequences are selected, and you will get result very, very close to this one now. And this was 1990, the paper, you see, that see, people, you see, this study. Now, this is 2025, and the people saying even after 40 years, the NEH algorithm is the best of these one. Now, let me see the applications. The applications are almost every field. It could be manufacturing, supply management, aviation, health services, other services. Everywhere you can find, you see, this application. Now, coming to this one very close to this, you see, talking about, see, is AI and the things here. Look at, you see, this one. You can use, now, as I said, you see, the algorithm can be used in data processing. And the people are getting, you see, applying, you see, this one to find the best sequence. And look at, see, I can use, see, this worldwide webs to find out the shapes. It is about, see, the computing within the system. How can you see the jobs are processed in the computer and your CP and your CIP, so the CPU and other things like that. Look at, see, how you see the people are using, see, this algorithm in their drone systems. You see this scheduling of these things. Okay, look, in satellite, it is recent paper. You see this using, you see, this is satellite communications, and how the the data is transferred from one satellite to the other. Same. look at say this, people are using, or researchers are using self-driving vehicle scheduling of data in this one. Down to these things in your scheduling of tasks in your GPUs. All these these applications are just relating to about this AI or computing or things like that. Now, this NIH algorithm has become part of university courses all over the world. These are people are using this teaching in your classrooms across the world. Asia, the most one is talk about this is Muslim countries, Indonesia, Turkey, Iran, Morocco. Lots of people are using this algorithm teaching in their own classrooms. You can see this algorithm in different books. That is to say, it easy. I just want to say, Namaz and score algorithm itself becomes a research topic. The people are working on this algorithm. How does it work? How different types of variations have been developed for apply to different areas of the theme. So you can see
you have 2 minutes, please. You have 2 minutes.
Okay, just 1 minute quickly on this one. And look at this one. I just want to show this at the end. You can see so many different this terms used as NIH algorithm or inspire. And the main thing I just want to show, the last one is where you see the people are using this Nawaz algorithm in different countries. This one, and in terms of Muslim countries, it is Iran and Turkey. These are mostly people are using, and they are teaching the algorithm in their thing. And this paper have published in this one, and shows where NIH algorithm is being applied, how being the people in different. Looking at the dark one, that is more and light color, very small. So look at that it is China, India, Iran, Turkey, and I can see there are people people are teaching in Morocco and Algeria and other thing people are saying. And other thing in terms is China, this Brazil, USA, and other places. So it is almost 70 countries are using the are working or publishing papers using the algorithm in the. Now it comes to say this one. This is the most cited by Pakistani researchers, or the most cited by Pakistani engineers, and this is the only Pakistani work that is the people are using. See, this is Nawaz. It is first paper the research named after Pakistani, and I think this is the only. This is one of the papers. This is in the Muslim countries. This is. I think this is very good contribution from the Islamic community to the world. Any questions? I'm here to help you anytime you like.
Thank you.
Well, thank you very much. I want to thank all the speakers in session 2, and we now move to session 3. So I will give the floor to Professor Badran to start the roundtable discussion. So please, Professor.
Okay. Well, first of all, I want to thank you all. And I want to thank all the speakers for their contribution. And also I want to thank all those who attended this conference. I think this conference, the title of it, was discussed, if you remember, at our Pakistani meeting in Islamabad. And the Islamabad, our meeting, our conference was about WEF, water, energy, food security, and ecosphere nexus in the OIC countries. Today, we've discussed AI and nanotechnology. AI and nanotechnology is going to be a frontier area in scientific research and really in the development of industry, agriculture, and the infrastructure of the world. It's going to be very influential. We've enjoyed listening to you, the keynote addresses by Atta-Ur-Rahman, by Munir Nayfeh, and by Choudhary. And also we've enjoyed listening to your papers, which was presented by you in the area of AI and nanotechnology, the nexus of AI with nanotechnology. Research in AI is booming and rising. And research in nanoscience also is booming and rising. Both, they form a nexus for a better future. But remember, scientific achievement always has two sides of the coin. One side is beneficial to humanity. Humanity development, overcoming unemployment, of new opportunities will be open. New venues will be open. And also another side of the coin, the peril, the terror may produce. Exactly like fission and fusion of atoms. The nuclear research produced electricity, medical health improvement, but also produced mass destruction armory. So again, as we talk to science and scientists, I think we have to be very careful in our future research in AI and nanoscience. Ethics is so important, as Prince Hassan in his address today said it very clearly. We have to be sided with humanity, not with the mass destruction of humanity. The human being is the central or the center of our planet, the human being, and should be preserved. Civilization should be preserved. Friendship and understanding between people should be preserved. And anything will lead to conflict, we should not, as scientists, support. We should not support it as scientists. Delivery of science, delivery of AI, delivery of nanoscience should go to peace building, not to build hatred, conflicts, and wars. With those remarks, I want to open the discussion, and also at the end of the discussion, and the discussion will be led by Professor Shahir Momani. He will steer the discussion, and at the end of the discussion, Shahir Momani will read to you the declaration, you see, and to hear your comments about the declaration. And this declaration will go to the heads of the state of OIC countries, plus regional and international organizations. What do we think as scientists of the Islamic world about the nexus of AI and nanoscience or nanotechnology. Professor Shahir.
Thank you, Professor Badran. First of all, I will start with the Professor Ilyas. If you have any comments, then we will proceed to other guests. You don't, okay.
Thank you, Professor Momani. I have no comments to add to what Dr. Badran said.
Okay,
Thank you.
If you have any questions from the respected speakers or any respected fellows, we can directly ask Professor Badran about anything regarding the nanoscience and artificial intelligence issues. Okay, Professor Noor, you can ask your question.
Thank you very much. I have a very short comment on the AI and nanotechnology nexus. One is that nanotechnology needs a building of the things. When we designed with AI, we have to build the thing at a nanoscale, and that involves nanoengineering. So I think it is important to both are things, unless the thing is made and it works, we have no guarantee that the design is correct or not. A lot of this is, as an experimentalist, everybody knows this. There is always a slip between the cup and the lip. So what my contention is that one should be very careful in defining the designing in a very accurate way, matching the requirement of accuracy of the very critical fields which I mentioned, like nuclear and air, where we cannot take the risk of just trying it. It has to be first experimentally verified and then utilized. The second thing I want to suggest that since our experience of a multidisciplinary teaching at the undergraduate level is very important, and it has given good dividends. Instead of teaching usually one subject, there is a concept now for the last decade or so going on to have multiple discipline teaching at that level, so that the ground and foundation of the student is better when he goes to the university for research. So these are the two recommendations which I wanted to comment on, particularly the use of AI as a coupled with nanoengineering to be more useful. Thank you for my
Thank you.
Thank you very much, Professor. If you like to, he suggests that we should be very careful with dealing with AI.
Okay. We shall proceed.
Yes, thank you.
I think Dr. Badran suggested that too in his higher education paper. No, we should be careful using the AI.
Professor Malik?
Yeah.
Professor Malik Maza? Okay. We can ask you a question?
Thank you so much. It's just a remark. It's not a question by say. First of all, I really endorse what our president has stated. Science sans conscience n'est que ruine de l'âme. And therefore, in that regard, it is extremely important that we should come with regulation in AI, as well as not only in terms of ethics, but jurisdictions also.
Yeah.
It's really critical. And within the Islamic world, I think it should be normally natural to have a common chart to all members of the COMSTECH and the Islamic world in general. And also to recommend that our young generation should all of them be informed about the opportunities.
Yes.
And also ensure that they will have some philosophy background, because the sad story is that in the hard sciences, we do not have a chance to have some basic courses on philosophy, and it's a must. It's a truly must. Thank you.
Thank you, Professor Malik. Any question, please, or any comment?
I say a
Munir,
comment.
yes, please. Professor Munir.
Yeah, a few years back, we were talking about the use of nanotechnology in the human body. And we were thinking like robots, tiny, tiny robots. And we were all thinking about this stuff as science fiction. Changing genes, this, that.
Science fiction.
But I think at this juncture,
effect.
yes, at this juncture, we should be careful because artificial intelligence, with being able to work out on diseases and find out how the protein folds and how they express themselves, we should be careful about turning it around to change what is working in the body now, rather than solving disease. And the ethics of this and being behind also in the OIC in this area would be very, very dangerous. So I think the combination of nanotechnology with artificial intelligence and with advancements in computation, quantum computers, or parallel computing should be looked at in the Muslim world.
Right.
Thank you, Professor Munir. Any comments?
Anyone?
Hello.
Yes, Professor Badran.
Hello.
Always I wonder how, really, progress right now is very much linked to how far we can go in the OIC countries in the frontier areas of science. How we could lead in that part. And now we talk about AI and nanoscience. I think really our academy should look, we are a platform, as you know. We are a platform. We have IAS newsletter every 2 months. We put up to date about new findings in science and technology. And also we put some ideas and reports and some scientific articles every 2 months, bi-monthly. And we come out with this conference, which is entitled AI and Nanotechnology, which all your papers will be published in the proceeding of this conference and will reach you electronically, online. But this is not enough. I think we have to look how we do something collectively. How could we use the network, which is not costly, without cost, between centers of excellence, and to develop really exchange of ideas, exchange of meetings. And something like this, I think, South-South cooperation is so important nowadays, because really science is becoming what I call secret of the corporate. and is going to be science more secretly for the corporates, because leading to patents, new inventions, market economy, competition. How we in the Islamic world can survive to really become productive in the frontier area of science. And this is, we have to look at in the future, to network in every field of science between centers of excellence across borders in the Islamic world. And I do thank you for your interventions and for your deliberations in this conference. And now, if you allow me to ask the chair to really present to us at the end of this dialogue and this part of our conference, to present the declaration. And after we finish the declaration and approve it, we will go into a legislative meeting of our council, a meeting of our assembly. And by that, we'll end our conference for today. Professor Munir.
Can I say one word, please?
Yes, please, yes. Yes, Professor Muhammad.
Hello?
You can speak now.
You muted, but I think.
No, we can hear you.
Hello, Assalamu alaikum.
Alaikum salam.
I just want to say that you say that yes, it is good say to apply for the things, but at the same time, the students need to learn. The students need to learn the basics, just like you see, as I say, that NEH algorithm, that is the basics of the scheduling. Why you see the people actually, why the computer works inside, not just to see the application of the things. So that's see. And the second thing is that the Muslim persons or Muslim researchers or Muslim academics work to less the other people. So the universities to teach Muslim work too. At this time, that is Nawaz algorithm is very, very commonly used in so many different countries, like in China, Germany, France, and other things. It is not too much in, for example, just like myself, it's I say look at in Pakistan, not many people are using my work, whereas if you consider this is China or Brazil or Spain, it's very, very common, and the people are using in the classrooms, doing a research on this one. The people are working about it. So the thing is that Pakistan, Muslim workers, Muslims' work should be also promoted in the Muslim countries too. Thanks.
Thank you very much. Thank you very much for your comments. Let me start. Conference Declaration of the 26th Islamic World Academy of Sciences Conference on Artificial Intelligence and Nanotechnology Nexus, adopted in Amman, Jordan on the 8th of Jumada al-Ula, 1447 Hijri, the 30th of October 2025. The Islamic World Academy of Sciences, IAS, and the Higher Council for Science and Technology, HCST, extend their appreciation and gratitude to His Excellency, the President of Pakistan, and His Royal Highness, Prince El-Hassan bin Talal, founding patrons of the Islamic World Academy of Sciences. Preamble. Whereas artificial intelligence and nanotechnology are converging to form a powerful nexus capable of reshaping economies, healthcare, education, sustainability, and the way societies solve complex challenges. Whereas the Islamic world, with its historical legacy of scientific innovation and its contemporary human intellectual capital is uniquely positioned to contribute meaningfully to global scientific and technological advancement. Whereas the responsible and ethical development of emerging technologies must be guided by inclusive governance, shared values, and a commitment to equitable progress to all human dignity. Whereas the SDGs 2030 call on all countries of the world to enhance scientific achievements and technology towards eliminating poverty and provide new opportunities in the forthcoming industrial revolution. Therefore, the Islamic World Academy of Sciences, IAS, recognizing the transformative potential of artificial intelligence, AI, and nanotechnology in addressing some of the most pressing challenges facing humanity. Acknowledging the rich scientific legacy of contemporary responsibility of the Islamic world and contributing to global knowledge and technology for the benefit of all people. Recalling the mission of the Islamic World Academy of Sciences, IAS, to foster excellence in science and technology through cooperation, capacity building, and the dissemination of knowledge. Therefore, we, the participants of the International Conference on Artificial Intelligence, Nanotechnology Nexus, hereby recognize the convergence of AI and nanotechnology presents unprecedented opportunities to innovation in water, energy, food, security, climate change nexus, healthcare, agriculture, environments, material science, security, and beyond. When combined, these technologies can enable intelligent, autonomous, and highly precise systems capable of addressing complex societal changes. Call for the development and application of AI and nanoscience in a manner that is ethical, transparent, and inclusive, guided by human dignity and sustainability. Urge national governments, regional institutions, universities, and scientific bodies across the Islamic world to invest in education, research, and infrastructure that supports interdisciplinary work in AI and nanotechnology. This includes empowering youth, women, and marginal groups in science and innovation. Recommend the establishment of international interinstitutional platforms for collaboration among scientists, policymakers, industry leaders, and civil society actors to jointly shape the trajectory of AI, nanotechnology, research, and regulation. Emphasize that AI and nanotechnology must serve the 2030 Sustainability Development Goals and be directed toward eradicating poverty, improving health, mitigating climate change, and advancing social equity. We call for technology that is both accessible and affordable for low and middle income countries. Recommendations. To advance the aims outlined in this declaration, the conference recommends the following. First, develop a network between centers of excellence in the Islamic world for training and joint research work and exchange of the delivery of the research projects on AI and nanoscience Nexus to promote innovation and technologies in this new orbit of knowledge and the human order leading to peace and development of all humanity. Second, create national AI and nanotechnology strategies across OIC member states align with ethical principles and the SDGs. Third, establish dedicated funding mechanism and research grants to support interdisciplinary projects in AI and nanoscience across the Islamic world. Fourth, develop technology incubators and startup companies that support early stage innovation and empower youth-led initiatives in AI and nanotech applications. Fifth, establish international partnership with leading global institutions to transfer knowledge, share best practice, and ensure the Islamic world is engaged in shaping the global governance of emerging technologies. Six, promote inclusive public dialogue and ethical awareness, ensuring that communities across the Islamic world understand both the benefits and risks of these technologies. Thank you.
Very well. Thank you, Professor Bowman. Now, with this declaration, if you have any comment, I would welcome it. So, if it's not, then we could.
Professor Badran,
we could approve it as declaration of our conference, which will be distributed to the OIC Secretariat and OIC countries. Okay.
I have one.
Approved. Now we come to.
I have one simple comment in the which is should be new addition.
Yes, please. Yes. Yes, you can add your comment, please. Professor Noor?
Yeah,
Yes.
this very quick. You see, all technologies have regulations and standards of safety to prevent the harmful effects of that technology. I suggest that one line should be added in this recommendation that regulatory and safety standards should be instituted for the use of AI in nanotechnology Nexus to prevent any harmful effects. You know, all technologies have it. In fact, since many years, some regulations internationally even not available on nanotechnology, as they are standards of chemical sciences and other safety standards. So there is a room for this regulatory aspects and safety standards in this important technology, which is forthcoming in the future years. Thank you.
Thank you. If he can send it by email, Professor, send your recommendation by email so we can add it to the declaration.
Okay. Okay. Thank you very much. I'll do.
Yeah.
Now we have to conclude session 3 and we will start session 4, the meeting, the General Council meeting. So I have to withdraw and join you on this.
Thanks a lot, Professor Munir.
بس زملاء لازم بس زملاء
ننهي المؤتمر. Thanks a lot for your participation with us and bearing with us all day long. Now we have a meeting only for the council members, which will take like 20 minutes, and then we call for the General Assembly. So please, those who are not in the council meeting, they can relax now for like 20 minutes, then join us again.